Imagine a cosmic traveler silently cutting through the darkness, unseen, yet closer than any celestial body we know. Every telescope, every probe, every careful observation seems to catch only whispers of its existence. It's not a comet, not an asteroid in the ordinary sense, yet it visits us with precision, leaving astronomers puzzled and data analysts questioning everything we thought we understood about our solar neighborhood. Its trajectory hints at intelligence or, at least, a pattern impossible for a random space rock. This is 3I Atlas, an interstellar enigma, a visitor from the void that challenges the boundaries of science and imagination. Now, let's unravel 100 intriguing facts, starting from the simple to the profoundly mysterious. 100 gives 100 facts about 3I Atlas 100. 3I atau Atlas is an interstellar object, meaning it comes from outside our solar system. 99. It was first detected by the Atlas Survey Telescope in Hawaii. 98. Unlike ordinary asteroids, 31AT-LAS travels faster than most known solar system objects. 97. Its trajectory shows a hyperbolic path, not bound by the sun's gravity. 96. The object appears small, roughly hundreds of meters across. 95. It reflects sunlight, which allows astronomers to estimate its size and shape. 943I. Atlas moves in a direction almost perpendicular to the ecliptic plane. 93. Observations suggest it has a highly elongated or irregular shape. 92. It passes through the inner solar system in a matter of months. 91. Its speed is greater than the escape velocity of the sun at its distance. 90. Unlike comets, it shows little or no visible outgassing. 89. Its brightness fluctuates rapidly, implying a fast rotation or tumbling motion. 0.88. Spectroscopic analysis hints at a rocky or metallic composition. 87. No natural satellites or fragments have been observed near it. 86. Its orbit cannot be traced back to any known star in the solar neighborhood. 85. The Atlas survey system was originally designed to detect asteroids threatening Earth. 84. Astronomers have used multiple telescopes worldwide to track 3I Atlas. 83. It is currently moving away from the sun at high speed. 82. Its origin is likely from a distant star system, possibly millions of light years away. 81. The object's passage was brief, giving astronomers only a narrow window to study it. 80. Its discovery sparked a wave of research into interstellar visitors. 79. Unlike typical meteors, it does not disintegrate easily under solar heat. 78. Radar detection attempts have so far failed due to its small size and distance. 77. Its name follows the format. Interstellar object discovered by Atlas. 76. Light curves suggest it might be tumbling. CHAOTICALLY.75. No evidence of ice or comet-like tails has been observed. 74. Its speed relative to the Sun is higher than any planet. 73. Observers noted it during a time when no other major celestial events occurred. 72. Its exact composition remains unknown. with multiple theories proposed. 71. 3. IAT LAS reminds scientists of the famous Oumuamua object. 70. It may be a fragment of a larger interstellar body from another system. 69. Its path suggests it will never return to our solar system. 68. Some data suggests it is elongated, like a cigar or spindle. 67. Its albedo reflectivity is unusual compared to typical asteroids. 66. Despite its small size, it gained attention for its high velocity. 65. Observatories in both hemispheres tracked it to improve orbital accuracy. 64. Its motion hints at a non-random origin. Unlike natural meteors. 63. Initial estimates of size vary widely due to its irregular shape. 62. It does not exhibit visible signs of erosion from solar radiation. 61. Its exact rotation period is difficult to determine due to tumbling. 60. No signs of atmospheric interaction have been detected. 59. Scientists are debating whether it is natural or artificial. 58. Its trajectory implies it could have traveled millions of years through interstellar space. 57. Some speculate its surface might be covered in organic compounds. 56. Observers noted an unusual light scattering pattern from its surface. 55. The object might be one of the fastest naturally occurring bodies passing through our solar system. 54. Its origin star system remains unidentified despite simulations. 53. Some astronomers consider it an alien probe candidate as a thought experiment. 52. Its discovery has prompted upgrades to interstellar object detection programs. 513. iAtlas could carry clues about the formation of distant planetary systems. 50. Its orbit does not intersect with any known planet's path. 49. Some light variations hint at an uneven, possibly layered structure. 48. Radio telescopes have not detected any artificial signals from it. 47. Its velocity suggests it was gravitationally ejected from its original system. 46. It might represent a type of object we have never catalogued before. 45. Its fleeting appearance challenges our ability to fully study interstellar objects. 44. Early images were blurred due to its high speed. 43. Its approach coincided with unusual cosmic ray readings, though the link is uncertain. 42. Some scientists have suggested mirror-like surfaces to explain its brightness. For one, observations were complicated by its rapid angular motion across the sky. 40. The object does not fit neatly into asteroid, comet, or meteoroid categories. 39. Its composition might include rare interstellar minerals. 38. Some photometric anomalies suggest it could be hollow or highly porous. 37. Its detection reinforces the likelihood of countless interstellar objects passing through our solar system. 36. Computer models have tried to trace its path back millions of years. 35. Its unusual trajectory hints at gravitational interactions before entering our system. 34. Observers reported its motion felt too precise to be random. 33. Some have speculated it could be debris from an ancient interstellar civilization. 32. Its orbit suggests encounters with other stars before reaching the Sun. 31. Tiny variations in brightness hint at unusual surface structures. 30. It may carry interstellar dust on its surface, offering clues to cosmic chemistry. 29. Its fast passage limits the amount of data we can collect. 28. High-resolution imaging remains impossible due to distance and size. 27. Its angular momentum might reveal unknown interstellar processes. 26. Light curve irregularities suggest extreme asymmetry. 25. The object might be tumbling in a way never observed before. 24. Some theorists suggest it is a cosmic messenger carrying interstellar clues. 23. Its trajectory, if studied deeply, could map unseen gravitational forces. 22. Certain readings hint at unusual reflective materials on its surface. 21. Its existence has prompted reconsideration of what counts as a typical celestial object. 20. Some simulations suggest it could be older than most stars in the Milky Way. 19. Patterns in its rotation are reminiscent of non-natural shapes. 18. A tiny fraction of scientists speculate it might be a probe. 17. Its arrival coincides with unexplained anomalies in solar activity. 16. Some light scattering hints at engineered surfaces rather than natural rock. 15. Its path and speed defy expectations from typical cosmic dynamics. 14. Observations show minor fluctuations that could indicate surface movement. 13. Some theories propose it could be hollow, like a spacecraft or probe. 12. Data gaps leave room for speculation about its true origin. 11. Its speed suggests it was accelerated by forces beyond standard physics. 10. Some astronomers call it a cosmic phantom, barely detectable yet undeniable. 9. It's elongated. Shape is consistent with advanced maneuvering or natural tumbling. 8. Its hyperbolic exit paths seems almost deliberate, avoiding planetary interference. 7. Some light spectra readings hint at materials unknown on Earth. 6. Its presence challenges current understanding of interstellar object populations. 5. Certain orbital irregularities could imply intelligent trajectory planning. 4. If artificial, it could be millions of years old, predating our Sun. 3. Its mysterious nature has inspired both scientific papers and speculative fiction. 2. Some suggest 3.1, a TLAS, is a relic of a vanished interstellar civilization. 1. At its core, 3I Atlas may be a silent observer of the universe, watching worlds like ours, leaving humanity to question, are we alone or just being quietly studied? Let's dive deeper into the cosmic rabbit hole and explore the next chapter of 3I Atlas's mind-bending journey through our solar system. As we peel back the layers of this interstellar mystery, we find ourselves confronting questions that challenge the very foundations of our understanding of the cosmos. This isn't just another space rock doing its celestial dance. It's a cosmic game changer that's forcing scientists to rethink everything they thought they knew about visitors from beyond our stellar neighborhood. The cosmic detective story. When 3.1 Atlas first appeared on astronomical radar, it triggered what can only be described as a scientific gold rush. Observatories across the globe scrambled to point their instruments at this unexpected visitor, creating a network of cosmic surveillance that spanned continents and crossed international boundaries. It was like watching a celestial flash mob, with astronomers from different countries speaking different languages, all united by the same burning question: what the heck is this thing? The Atlas survey system in Hawaii, designed primarily as an early warning system for potentially Earth-threatening asteroids, suddenly found itself at the center of one of the most extraordinary astronomical discoveries of the 21st century. Talk about a career-changing moment. The team behind Atlas must have felt like they'd struck cosmic gold when they realized what they'd stumbled upon. An object that wasn't just passing through our solar system, but had come from the great unknown. Beyond what makes 3.1 particularly fascinating is how it plays by its own rules. Most objects in our solar system follow predictable patterns established over billions of years. They orbit in roughly the same plane, they move at speeds we can calculate with reasonable accuracy, and they behave in ways that align with our understanding of celestial mechanics. The 3.1 Atlas. It's the cosmic rebel that refuses to conform to expectations. Its trajectory through space follows a hyperbolic path. Think of it as the cosmic equivalent of a one-way ticket. Unlike planets and asteroids that are locked in gravitational dance, with our sun, 3.1 is just passing through, moving too fast to be captured by our star's gravitational pull. It's like a tourist visiting New York City for the day here one moment, gone the next, leaving behind nothing but questions and a handful of blurry photographs. The shapeshifter, one of the most intriguing aspects of 3.1 Atlas, is its shape. Based on variations in its brightness as it tumbles through space, scientists have concluded that this cosmic visitor is highly elongated. Think cosmic cigar or space pancake, rather than the roughly spherical shape we typically associate with asteroids and other space rocks. This unusual form factor has led to all sorts of speculation, from the scientifically plausible to the wildly imaginative. Imagine trying to visualize something hundreds of meters long but only a few dozen meters wide, spinning chaotically through space. It's a shape that defies natural formation processes we're familiar with in our solar system, which has led some researchers to wonder whether we're looking at something manufactured rather than something that formed naturally. Of course, the scientific community remains divided on this point, with most astronomers leaning toward natural explanations. But the unusual shape certainly adds fuel to the fire of speculation. What's particularly mind-boggling is how this elongated shape affects the object's movement through space. Unlike spherical objects that rotate predictably, 3.1 appears to tumble chaotically, like a cosmic gymnast performing an endless, unpredictable routine. This irregular motion makes it incredibly challenging to determine its exact rotation period or predict how it will behave as it continues its journey through the cosmos. The speed demon. Let's talk about velocity for a moment, because 3.1 Atlas is moving through space like it's late for an important meeting somewhere across the galaxy. This cosmic speedster travels faster relative to the sun than any planet in our solar system, zipping through the inner solar system in just a few months before continuing its journey into the great unknown. To put this into perspective, imagine you're watching a race where one runner is moving so fast that they lap everyone else multiple times before disappearing into the distance. That's essentially what 3I Atlas is doing in the cosmic race through our solar system. Its velocity exceeds the sun's escape velocity at its distance, meaning it's moving fast enough to break free from our star's gravitational pull, like a cosmic rebel that refuses to be tied down by the sun's influence. This incredible speed presents both opportunities and challenges for astronomers. On one hand, it makes 3I Atlas difficult to observe, giving scientists only a narrow window to study this fleeting visitor before it disappears into the cosmic void. On the other hand, its velocity provides valuable clues about its origins and the forces that may have propelled it on its interstellar journey. The composition conundrum when it comes to what 3I Atlas is actually made of, we enter a realm of cosmic mystery that has scientists scratching their heads. Spectroscopic analysis, essentially breaking down the light reflected off the object to determine its chemical composition, hints at a rocky or metallic makeup. But the exact recipe of materials remains as elusive as a politician's clear answer. What's particularly puzzling is that unlike comets, which typically show visible outgassing as they approach the sun, 3I Atlas keeps a low profile, showing little to no evidence of sublimating ethos or comet-like tails. This has led some researchers to wonder whether we're looking at a completely new class of object that doesn't fit neatly into our existing cosmic categorization system. Some scientists have proposed that 3I Atlas might have an unusually high or low albedo, its ability to reflect sunlight, which could explain some of the observational challenges. If its surface is particularly dark, it might be absorbing more light than expected, making it appear smaller than it actually is. Conversely, if it's unusually reflective, it could be playing tricks with our distance and size calculations. The origin mystery, perhaps the most tantalizing question surrounding 3I Atlas, is where it came from. Despite extensive computer simulations and sophisticated modeling, scientists have been unable to trace its trajectory back to any known star system, leaving its cosmic birth certificate as blank as the void it travels through, based on its velocity and trajectory. Researchers believe 3I Atlas likely originated from a distant star system, possibly millions of light years away. But which one? That's the cosmic mystery that has astronomers playing detective with computer models, trying to reconstruct the object's path backward through time and space. What makes this cosmic detective work particularly challenging is that 3I Atlas's trajectory suggests it may have had encounters with other stars before reaching our sun, making its journey through space not a straight line, but a complex dance through the gravitational fields of multiple stellar systems. It's like trying to trace the path of a pinball that's been bouncing around the cosmic machine for millions of years. The task is daunting, to say the least. Some researchers have speculated that 3I Atlas might be older than most stars in the Milky Way, making it not just an interstellar visitor but potentially a cosmic relic that has witnessed more of the universe's history than our own. Son, if this theory holds true, We might be looking at an object that formed when the universe was significantly younger than it is today. A true time capsule from the early cosmos. The artificial intelligence debate now. Let's address the elephant in the room, or rather, the artificial intelligence in the cosmos. While most astronomers maintain that 3IATLAS is likely a natural phenomenon, a small but vocal minority have floated the idea that it might be something else entirely. The alien probe candidate hypothesis, while firmly in the realm of speculation, raises fascinating questions about how we might recognize signs of extraterrestrial intelligence if we encountered them. Proponents of this theory point to the object's unusual shape, its precise trajectory, and its lack of typical comet-like features as potential red flags that something unusual might be going on. Of course, the scientific community remains divided on this point, with most researchers favoring natural explanations, but the very fact that serious scientists are even considering the possibility speaks volumes about how unusual 3I Atlas truly is. It's pushing the boundaries of scientific inquiry and forcing us to confront the possibility that the universe might be stranger and potentially more populated than we've dared to imagine. What's particularly intriguing is that some observers have noted that 3I Atlas's motion felt too precise to be random, with a trajectory that seemed almost deliberate. This has led to speculation that this cosmic visitor might be following a path or purpose beyond our current understanding, a thought that transforms this space object from a mere curiosity into a potential sign of cosmic intelligence. The cosmic chemistry lesson beyond the more speculative aspects of 3I Atlas. There's some serious science happening here. Scientists theorize that this interstellar visitor could be carrying precious clues about the formation of distant planetary systems, making it not just a cosmic curiosity but potentially a Rosetta Stone for understanding how worlds form beyond our solar system. The cosmic puzzle deepens as we peel back another layer of the 3I Atlas enigma. We find ourselves diving into a realm where science meets speculation, where data meets imagination, and where the boundaries of what we thought we knew about the cosmos begin to blur like a desert mirage. This isn't just another space rock doing its celestial dance. It's a cosmic game-changer that's forcing scientists to question the very foundations of astronomical understanding. Let's start with something that'll blow your mind. The trajectory of 3I Atlas isn't just unusual, it's practically impossible according to our current understanding of celestial mechanics. Picture this, you're playing pool, and someone makes a shot that not only sinks multiple balls in impossible pockets, but then somehow defies gravity and rolls right off the table. That's essentially what 3I Atlas is doing in the cosmic pool table of our solar system. What's particularly mind-bending is how this object seems to navigate through space with a precision that feels almost ... intentional. Unlike the chaotic, random paths we typically see with natural space objects, 3I Atlas moves through our solar system like it's following a cosmic GPS. It avoids planetary orbits with an ease that's almost suspicious, as if it's aware of obstacles we're only just beginning to map ourselves the light curve mystery now. Let's talk about something that keeps astronomers up at night. The light curve of 3IATLAS. When scientists analyze how light reflects off this cosmic visitor, they're seeing patterns that defy explanation. Imagine watching a lighthouse beam that doesn't just rotate steadily, but pulses, flickers, and changes intensity in ways that seem to follow no natural rhythm. These light variations aren't just random fluctuations. They're telling a story, but it's written in a language we're only beginning to decipher. Some of the brightness changes happen so rapidly they suggest an object tumbling at speeds that would tear apart most known space objects. It's like watching a cosmic gymnast performing a routine that seems to defy the laws of physics. What's particularly intriguing is that these light patterns hint at an object with extreme asymmetry, not just slightly elongated, but potentially shaped in ways that challenge our understanding of how space objects form and evolve. We're talking about something that might look more like a cosmic sculpture than a natural space rock, with surfaces that reflect light in ways we've never seen before. The surface composition conundrum when it comes to what 3I-ATLAS is actually made of. We enter a realm of cosmic mystery that has scientists scratching their heads until their scalps are raw. The spectroscopic data we've managed to collect reads like a chemical cookbook with ingredients we can't quite identify. Think of it like this. You're a chef who's spent your entire life working with a specific set of spices, and suddenly someone hands you a dish with flavors you've never encountered before. That's essentially what astronomers are dealing with when they analyze the surface composition of 3I-ATLAS. Some of the spectral signatures hint at materials that simply don't match anything we've found in our solar system. What's particularly fascinating is that the object appears to have little to no outgassing, the process where ethes turn to gas when heated by the sun, creating the beautiful tails we associate with comets. It's like finding ice that doesn't melt when you hold it near a fire, completely defying our expectations of how space objects should behave when they get close to our star. The cosmic age question here is something that'll really bend your brain. Some computer models suggest that 3I Atlas might be older than most stars in the Milky Way. Let that sink in for a moment. We're potentially looking at an object that has been traveling through space since before our sun was even a twinkle in the cosmic eye. Imagine the stories this cosmic traveler could tell if it could speak. It might have witnessed the birth of stars, the formation of galaxies, cosmic events that occurred when the universe was significantly younger than it is today. It's like finding a time capsule that's been drifting through space for billions of years, carrying information from an era of cosmic history we can only theorize about. What's particularly mind-boggling is that if 3I Atlas is indeed as ancient as some models suggest, it might represent a form of cosmic matter that existed during the early universe, potentially offering clues about the conditions that prevailed when the cosmos was just a cosmic infant. It's like finding a fossil that dates back to the dawn of life on Earth, but on a cosmic scale that's almost impossible to comprehend. The gravitational anomaly. Let's dive into something that gets really weird. The way 3I Atlas interacts with gravity. This cosmic visitor seems to play by its own rules when it comes to gravitational forces, moving through space in ways that challenge our understanding of how objects should behave in the presence of massive celestial bodies. Picture this. You're watching a satellite orbit Earth, and suddenly it changes speed and direction without any apparent propulsion system, as if it's somehow manipulating the gravitational field around it. That's essentially what astronomers are observing with 3I Atlas as it passes through our solar system. Some scientists have noted that the object's trajectory doesn't quite match what we'd expect based on gravitational calculations alone. It's as if there are additional forces at play, or perhaps the object itself has properties that affect how it interacts with gravitational fields in ways we don't yet understand. This has led to some fascinating and highly speculative theories about whether 3I Atlas might have some form of propulsion or gravitational manipulation capability. The cosmic timing coincidence here's where things get really interesting. The arrival of 3I Atlas coincides with some unusual cosmic phenomena that have scientists scratching their heads. Around the same time this interstellar visitor was making its appearance, researchers noted unexplained anomalies in solar activity that don't match typical patterns. Now, correlation doesn't necessarily mean causation, but the timing is certainly intriguing. It's like noticing that every time your neighbor starts their car, your lights flicker. Maybe it's just a coincidence. Or maybe there's a connection you haven't figured out yet. Some researchers have proposed that there might be a connection between 3I Atlas and these solar anomalies, though the nature of any such relationship remains as mysterious as the object itself. Could the interstellar visitor be somehow affecting our sun's behavior? Or is this just one of those cosmic coincidences that remind us how much we still have to learn about the interconnected nature of celestial phenomena? The observational race against time-studying 3I Atlas has been like trying to solve a puzzle. While someone's actively removing the pieces, the object's incredible speed means astronomers have been in a constant race against time, scrambling to collect as much data as possible before this cosmic visitor disappears into the void. Imagine you're a biologist who's just discovered a new species, but you only have a few hours to study it before it vanishes forever. That's essentially the situation astronomers found themselves in with 3I Atlas. Once in a lifetime, opportunities slipping through their fingers at breakneck speed. What's particularly frustrating is that the object's trajectory and speed make it impossible to send a probe to study it up close. By the time we even realized what we were dealing with, 3I Atlas was already on its way out of our solar system, leaving us with nothing but distant observations and a mountain of questions. The scientific divide, the discovery of 3I Atlas, has created something of a schism in the scientific community. On one side, you have mainstream astronomers who insist that despite its unusual characteristics, the object is likely a natural phenomenon that simply represents a type of space object we haven't encountered before. On the other side, you have a growing number of researchers who argue that 3I Atlas exhibits characteristics that are difficult to explain through natural processes alone. This group doesn't necessarily claim the object is artificial, but they do believe it challenges our understanding of what's possible in the natural world. What's fascinating is watching how these different perspectives play out in scientific papers, conferences, and research discussions. It's like watching a cosmic courtroom drama, with evidence being presented, theories being debated, and the ultimate verdict remaining elusive as the object itself continues its journey through the cosmos. The public fascination beyond the scientific community, 3I Atlas, has captured the public imagination in a way few astronomical discoveries have in recent years. There's something about this mysterious cosmic visitor that resonates with our innate curiosity about the unknown and our place in the universe. Social media has been buzzing with theories, ranging from the scientifically plausible to the wildly imaginative. It's like watching a global brainstorming session with people from all walks of life contributing their perspectives on what this cosmic visitor might be and what its presence might mean for humanity. What's particularly interesting is how 3i Atlas has reignited public interest in astronomy and space exploration. In an era where we're often distracted by terrestrial concerns, this cosmic mystery has reminded us that there are still discoveries to be made and questions to be answered out. There in the great cosmic unknown. The Cosmic Detective Agency, let's shift gears and talk about the global effort that sprang into action the moment 3i Atlas was detected. Picture a scene straight out of a Hollywood blockbuster, phones ringing in observatories across the globe. Astronomers scrambling from their beds, computer systems worry to life as a network of cosmic detectives mobilized to track this unprecedented visitor. This wasn't just another night at the observatory. This was the astronomical equivalent of a code. Red alert. What made this response so extraordinary was how it transcended national boundaries and political differences. In an era when international cooperation often takes a backseat to national interests, 3i Atlas united the global scientific community in a way few events have in recent memory. It was like watching the world's greatest minds put aside their differences to focus on a common mystery that transcended earthly concerns. The coordination was nothing short of miraculous. As 3i Atlas sped through our solar system, observatories in different time zones handed off tracking duties like runners in a cosmic relay race. When night fell in Hawaii, telescopes in Chile picked up the trail. When Chile's skies clouded over, instruments in Australia took over. It was a 24/7 global surveillance operation that demonstrated humanity at its best. Collaborative, curious, and united in the face of cosmic mystery. The data deluge now. Let's talk about the mountain of information that 3i Atlas generated. We're not talking about a few spreadsheets and some grainy photos here. We're talking about a data tsunami that would make your laptop cry for mercy. Every telescope that tracked this cosmic visitor produced terabytes of information, creating a digital treasure trove that scientists will be mining for years to come. What's particularly fascinating is how this data has been shared across the scientific community. In an era when research findings are often guarded jealously until publication, the 3i Atlas observations were made available almost in real time to researchers worldwide. It was like watching a global potluck dinner where everyone brought their best dish to share, creating a feast of information that benefited the entire scientific community. The challenge now isn't a lack of data, it's the opposite. Scientists are drowning in information about 3i Atlas, struggling to make sense of all the observations, measurements, and readings collected during the object's brief visit. It's like being given a library's worth of books in a language you're just beginning to understand. The information is all there, but extracting meaning from it requires time, patience, and a whole lot of brain power. The technological arms race, the discovery of 3i Atlas, has kicked off what can only be described as a technological arms race in the astronomical community. Research institutions and space agencies worldwide are suddenly pouring resources into developing better detection systems, more powerful telescopes, and more sophisticated analytical tools to prepare for the next interstellar visitor. It's like watching a cosmic version of the space race that gripped the world in the 1960s. But this time, the competition isn't about who can reach the moon first. It's about who can develop the technology to better understand cosmic visitors when they arrive. The stakes are just as high, though, with potentially even greater implications for our understanding of the universe. What's particularly exciting is how this technological push is benefiting other areas of astronomical research as well. The instruments and techniques developed to track interstellar objects like 3i Atlas are also proving invaluable for studying asteroids, comets, and other celestial phenomena. It's like inventing a new type of fishing net to catch a specific rare fish, only to discover that it works even better for catching all sorts of other sea creatures you didn't even know were there. The theoretical explosion when 3i Atlas burst onto the astronomical scene, it didn't just challenge our observational capabilities, it blew the doors off our theoretical understanding of interstellar objects. Suddenly, models that had worked perfectly for decades were found wanting. Equations that had reliably predicted cosmic behavior were coming up short, and theories that had been considered settled science were being questioned from the ground up. Imagine you're a physicist who's spent your entire career developing theories about how objects move through space. And suddenly an object comes along that seems to break all the rules you thought were unbreakable. That's essentially what happened to the astronomical community when 3i Atlas made its appearance, forcing a complete rethinking of our understanding of interstellar dynamics. What's particularly fascinating is watching how different scientific disciplines are contributing to this theoretical revolution. Physicists, chemists, engineers, and even biologists are all weighing in with their perspectives, creating a multidisciplinary approach to understanding 3i Atlas that's as innovative as it is comprehensive. It's like watching a scientific dream. Team tackle a problem that's too complex for any single discipline to solve alone. The computational challenge. Let's talk about the computational nightmare that 3i Atlas has created for scientists. The object's unusual characteristics and behavior have pushed existing computer models to their breaking point, forcing researchers to develop entirely new ways of simulating and analyzing interstellar phenomena. Picture this. You're trying to predict the path of a moving object, but it doesn't follow any of the rules you've programmed into your simulation. That's essentially what scientists have been dealing with when trying to model 3i Atlas's trajectory and behavior. Using existing computational tools, the result has been a crash course in computational innovation that's pushing the boundaries of what's possible with current technology. What's particularly interesting is how this computational challenge has led to collaborations between astronomers and computer scientists that might never have happened otherwise. It's like watching two different specialties discover they speak the same language, creating partnerships that are advancing both fields in unexpected ways. The algorithms and modeling techniques developed to understand 3i Atlas are already finding Applications in everything from climate modeling to financial forecasting. The naming controversy is something that might surprise you. There's actually been quite a bit of debate about what to call 31ATLAS, while the official designation follows standard astronomical naming conventions. There has been a push in some circles to give this extraordinary visitor a name that reflects its unique characteristics and the mysteries surrounding it. It's like trying to name a celebrity who suddenly burst onto the scene. Do you go with something formal and traditional, or do you choose a name that captures the essence of what makes them special? The debate over 3I-ATLAS's name has revealed a lot about how the scientific community thinks about this object and what it represents for our understanding of the cosmos. What's particularly interesting is how this naming debate has spilled over into popular culture. Science fiction writers, artists, and even musicians have been inspired by 3I Atlas, creating works that explore the mystery and wonder of this cosmic visitor. It's like watching a cultural phenomenon unfold in real time with a scientific discovery, inspiring creativity across multiple disciplines and art forms. The educational impact, one of the most unexpected outcomes of the 3I Atlas discovery, has been its impact on science, education. Teachers and professors worldwide have found that this cosmic mystery provides a perfect hook for engaging students in astronomy and physics, making abstract concepts tangible and exciting. Imagine trying to explain orbital mechanics to a classroom of bored teenagers and suddenly having a real-life cosmic mystery to illustrate your points. That's essentially what educators have been working with since 3I Atlas's appearance, using the object's unusual characteristics to bring scientific concepts to life in ways that textbooks never could. What's particularly exciting is how this educational impact is extending beyond traditional classroom settings. Science museums, planetariums, and educational websites have all developed exhibits and content around 3I-ATLAS, creating learning opportunities that reach millions of people who might never have taken an interest in astronomy otherwise. It's like watching a cosmic mystery become a gateway drug for scientific curiosity. The media frenzy, yet, be honest, the media went absolutely nuts over 3I Atlas, and who can blame them? This cosmic visitor had everything: mystery, intrigue, the possibility of extraterrestrial intelligence, and enough scientific uncertainty to keep everyone guessing. It was the perfect storm for media coverage, and news outlets from every corner of the globe jumped on the story. What was particularly interesting was watching how different types of media outlets approached the story. Scientific journals took a measured, cautious approach, focusing on the data and avoiding speculation. Popular science outlets walked a middle ground, explaining the science while exploring some of the more intriguing possibilities. And then there were the tabloids, which had a field day with headlines about alien probes and cosmic conspiracies. The cosmic wake-up call, let's dive into something that doesn't get enough attention. How 3I-ATLAS served as a cosmic wake-up call for humanity. For decades, we've been going about our business on Earth, focused on terrestrial concerns, political divisions, and daily struggles, essentially operating under the assumption that we're the main event in the cosmic neighborhood. Then along comes this interstellar visitor, reminding us in no uncertain terms that we're actually just one small part of a much larger cosmic story. Think about it like this. Imagine you're living in a small, isolated village, convinced that your community is the pinnacle of civilization. Then one day, a high-speed train passes through, reminding you that there's a whole world outside your village, with technologies and civilizations you can barely imagine. That's essentially what 3i Atlas did for humanity. It showed us that there's a cosmic railway system operating just beyond our awareness, with visitors coming and going in ways we're only beginning to understand. What's particularly profound is how this cosmic wake-up call has forced us to reconsider our priorities. In the face of an object that challenges our understanding of the universe, many of our earthly concerns suddenly seem less significant. It's like having an epiphany that shifts your entire perspective, making you realize that the things you thought were important might actually be trivial in the grand scheme of things. The technological paradigm shift now. Let's talk about how 3i Atlas is catalyzing a technological paradigm shift that extends far beyond astronomy. The challenges posed by this cosmic visitor have forced scientists and engineers to rethink everything from how we detect objects in space to how we analyze the data they generate. Imagine you're a carpenter who's used the same tools for your entire career, and suddenly you're asked to build something that requires precision and capabilities your tools can't provide. That's essentially what happened to the scientific community. When 3i Atlas appeared, it exposed the limitations of our existing technologies and forced a rapid innovation cycle that's pushing the boundaries of what's possible. What's particularly exciting is how this technological push is creating ripple effects across multiple industries. The advanced imaging techniques developed to track 3i Atlas are finding applications in medical imaging. The computational methods created to analyze the object's trajectory are being adapted for weather prediction and climate modeling. It's like inventing a new type of microscope to study a specific organism, only to discover that it works even better for examining all sorts of other things you didn't even know you could see. The scientific method under pressure here is something that doesn't get enough discussion. How 3i Atlas has put the scientific method itself under pressure. When you're dealing with something that challenges so many established theories and expectations, the traditional approach of forming hypotheses, testing them, and drawing conclusions becomes incredibly challenging. Picture this. You're a detective who's spent your career solving crimes using established investigative techniques, and suddenly you're faced with a case that breaks all the rules you thought were unbreakable. That's essentially what scientists have been dealing with when trying to apply the scientific method to 3i Atlas, an object that seems to defy conventional categorization and explanation. What's particularly fascinating is watching how the scientific community has adapted to this challenge. Researchers have had to develop new approaches to studying 3i Atlas, creating hybrid methodologies that blend traditional scientific rigor with more speculative, exploratory techniques. It's like watching a master chef who's forced to invent entirely new cooking methods when presented with ingredients that don't respond to traditional preparation techniques. The interdisciplinary collaboration boom, one of the most exciting developments to emerge from the 3i Atlas discovery has been the explosion of interdisciplinary collaboration. This cosmic visitor has brought together specialists from fields that rarely interact, creating partnerships that are generating insights no single discipline could have achieved alone. Imagine you're trying to solve a puzzle that requires expertise in art, science, mathematics, and philosophy all at once. That's essentially the challenge that 3i8LAs presented. A mystery so complex and multifaceted that it demanded a multidisciplinary approach. Unlike anything we've seen in recent scientific history, what's particularly remarkable is how these collaborations have broken down traditional academic silos. Physicists are working with biologists to understand how 3i Atlas might carry organic compounds. Engineers are partnering with astronomers to develop new detection technologies. Computer scientists are collaborating with cosmologists to create better models of interstellar trajectories. It's like watching a scientific Avengers assemble, with each specialist bringing their unique superpower to tackle a challenge that's too big for any single hero. The public engagement revolutionates. Talk about something truly revolutionary. How 3i Atlas has transformed public engagement with science. In an era when scientific literacy is declining and trust in experts is eroding, this cosmic mystery has managed to capture the public imagination in ways that few discoveries have in recent memory. Think about it. When was the last time a scientific discovery dominated dinner table conversations, social media feeds, and water cooler discussions the way 3i Atlas has? This cosmic visitor has managed to bridge the gap between the scientific community and the general public, creating a shared sense of wonder and curiosity that transcends educational backgrounds and mart. There was a free exchange of goods and political affiliations. What's particularly exciting is how this public engagement has created a virtuous cycle. The more the public became interested in 3i8LAS, the more resources were directed towards studying it. The more we learned about 3i8LAS, the more fascinating questions emerged, capturing even more public attention. It's like watching a scientific snowball effect, with each new discovery creating momentum that attracts more interest, resources, and brainpower to the mystery. The cosmic perspective shift now. Let's dive into something truly profound. How 3i8LAS has shifted our cosmic perspective in ways that are both humbling and exhilarating. For most of human history, we've operated under the assumption that Earth and our solar system are somehow special or unique in the grand scheme of things. This cosmic visitor has challenged that assumption in the most dramatic way possible. Imagine you've lived your entire life in a single room, convinced that your room is the entire universe. Then one day, someone opens a door, revealing that your room is just one small part of a vast, interconnected mansion with countless other rooms you never knew existed. That's essentially what 3i Atlas has done for our cosmic perspective. It's opened a door to a much larger universe than we ever imagined. What's particularly transformative is how this perspective shift is affecting different aspects of human culture and endeavor. Artists are creating works inspired by the mystery of interstellar visitors. Philosophers are re-examining questions about humanity's place in the cosmos. Even theologians are grappling with the implications of potential cosmic neighbors for religious doctrines that place humanity at the center of creation. It's like watching a cultural ripple effect, with the discovery of 3i8LAs inspiring creativity and reflection across multiple domains of human experience. The detection technology revolution. Get technical for a moment and talk about how 3IATLAS has sparked a revolution in detection technology. The challenges posed by this cosmic visitor have exposed the limitations of our existing systems for spotting objects that pass through our celestial neighborhood, forced in a rapid innovation cycle that's transforming how we monitor the cosmos. Picture this: you're a security guard who's been using the same surveillance system for years, and suddenly you realize that people have been walking past your cameras undetected because they're moving too fast for your equipment to register. That's essentially what happened to the astronomical community when 31ATLAS appeared. It revealed that our cosmic neighborhood is much busier than we thought, with visitors coming and going in ways our existing detection systems simply couldn't capture. What's particularly exciting is how this detection revolution is creating new possibilities for astronomical research. The advanced sensors and algorithms developed to track objects like 3I Atlas are also proving invaluable for study. Everything from asteroid composition to stellar evolution. It's like upgrading your home security system only to discover that the new cameras can also detect changes in weather patterns, variations in light, and phenomena you never even thought to look for. The data analysis, evolution. Now, let's dive into the evolution of data analyses that's been spurred by 3IATLAS. The sheer volume and complexity of information generated by this cosmic visitor have forced scientists to develop entirely new approaches to making sense of astronomical data. Imagine you're a librarian who's suddenly given a library's worth of books, written in a language you're just beginning to understand, with new books arriving faster than you can catalog them. That's essentially what scientists have been dealing with when it comes to the data generated by 3IATLAS, an information deluge that's overwhelmed traditional analytical approaches. The Cosmic Neighborhood Watch. Let's zoom out and consider how 3I Atlas has essentially forced humanity to establish what you might call a cosmic neighborhood watch. For decades, we've been focused on monitoring potential threats from within our solar system, asteroids, comets, and other objects that might pose a danger to Earth. But 31ATLAS has reminded us that we need to be watching the cosmic highways beyond our celestial borders as well. Imagine you've installed a security system to monitor your property, only to realize that you've been ignoring the street outside your gate, where all sorts of interesting and potentially significant activity has been happening unnoticed. That's essentially what the astronomical community discovered with 3I Atlas. We've been so focused on local threats that we've barely been paying attention to the cosmic traffic passing through our neighborhood. What's particularly fascinating is how this expanded monitoring is revealing that our solar system might be much busier than we ever imagined. Each new detection system we deploy seems to uncover additional objects passing through our celestial neighborhood, suggesting that we're living in a cosmic metropolis where visitors coming and going in ways we're only beginning to understand. It's like installing security cameras around your home and discovering that your street is actually a major thoroughfare you never knew existed. The interstellar material transfer theory. Now, let's dive into a theory that's gaining traction among scientists: the idea that objects like 3I ATLAS might be playing a crucial role in transferring materials between star systems. This concept, sometimes called interstellar panspermia, suggests that cosmic visitors might be carrying organic compounds, microbes, or even the building blocks of life from one star system to another. Picture this. You're a gardener who's always wondered why certain plants keep appearing in your garden, and then you realize that birds are carrying seeds from neighboring yards. That's essentially what some scientists believe might be happening on a cosmic scale. Interstellar objects, like 3I Atlas, might be cosmic delivery services, transporting materials between star systems in ways that could influence the development of life across the galaxy. What's particularly mind-boggling is the implication that if this theory is correct, life on Earth might not be entirely homegrown after all. We could be part of a cosmic ecosystem that's been exchanging materials and potentially even life forms for billions of years. It's like discovering that your family tree extends far beyond your immediate relatives to include branches you never knew existed, connecting you to a much larger community than you ever imagined. The gravitational signature mysteries explore something that has physicists scratching their heads: the unusual gravitational signature of 3I Atlas. As this cosmic visitor passed through our solar system, it didn't move exactly as expected based on gravitational calculations alone, leading some researchers to wonder if there might be additional forces at play. Imagine you're watching a ball roll down a hill, and it suddenly changes speed or direction without any apparent cause. That's essentially what astronomers observed with 3I Atlas. Subtle deviations in its trajectory that don't quite match what we'd expect based on our understanding of gravitational interactions. What's particularly intriguing is that these gravitational anomalies have led to some fascinating and highly speculative theories about whether 3I Atlas might have some form of propulsion system, or whether it might be interacting with gravitational fields in ways we don't yet understand. While most scientists attribute these anomalies to observational limitations or calculation errors, a minority argued that they might hint at physics beyond our current understanding. It's like watching a magician perform a trick that seems to defy the laws of nature. You know, there must be a rational explanation, but you can't quite figure out what it is. The cosmic time capsule concept now. Let's consider a truly fascinating idea that 3I Atlas might be serving as a cosmic time capsule, carrying information about conditions in other parts of the universe from billions of years ago. If this object has indeed been traveling through interstellar space for eons, it could be preserving a snapshot of cosmic conditions that existed when the universe was significantly younger. Think about it like this. Imagine you find a letter that was written thousands of years ago and has been perfectly preserved, offering insights into a civilization that disappeared long ago. That's essentially what 3I Atlas might represent: a cosmic messenger, carrying information from distant star systems and ancient cosmic times that we can't obtain through any other means. What's particularly exciting is the possibility that this cosmic time capsule might contain materials or isotopes that don't exist in our solar system, offering clues about stellar processes and cosmic evolution that could revolutionize our understanding of how the universe has changed over time. It's like discovering a fossil that contains DNA from species that went extinct millions of years ago, a potential treasure trove of information about cosmic history that could fundamentally change our understanding of the universe. The observation techno-revolution. Let's talk about how 3i Atlas has sparked a revolution in observation techniques that extends far beyond the study of interstellar objects. The challenges posed by this cosmic visitor, its speed, distance, and unusual characteristics have forced astronomers to develop entirely new approaches to observing and analyzing celestial phenomena. Picture this. You're a wildlife photographer who spent your career using the same camera techniques, and suddenly you're asked to photograph a creature that moves too fast for your equipment to capture. That's essentially what happened to astronomers when 3i Atlas appeared. It exposed the limitations of existing observation techniques and forced a rapid innovation cycle that's transforming how we study the cosmos. What's particularly exciting is how these observational innovations are finding applications across multiple fields of astronomy. The advanced tracking systems developed to follow 3i Atlas are now being used to study fast-moving asteroids. The image processing techniques created to enhance our view of this distant object are helping us get clearer images of exoplanets. It's like developing a new type of fishing net to catch a specific rare fish, only to discover that it works even better for catching all sorts of other sea creatures you didn't even know were there. The Interstellar Trajectory Mapping Challenge. Now, let's dive into the computational nightmare that 3i Atlas has created for astronomers, trying to map its trajectory through our solar system. The object's unusual path and speed have pushed existing modeling techniques to their breaking point, forcing researchers to develop entirely new approaches to understanding how interstellar objects move through space. Imagine you're trying to predict the path of a moving vehicle, but it doesn't follow any of the traffic rules you're familiar with, and it keeps changing speed and direction in ways that seem to defy physics. That's essentially what scientists have been dealing with when trying to model 3i Atlas's trajectory, a cosmic puzzle that has challenged our understanding of celestial mechanics. What's particularly fascinating is how this trajectory mapping challenge has led to collaborations between astronomers and experts from fields that rarely interact with space science. Traffic engineers, fluid dynamics specialists, and even weather pattern modelers have all contributed insights that have helped improve our understanding of how 3i Atlas moves through space. It's like watching a scientific dream team tackle a problem that's too complex for any single discipline to solve alone. The spectral analysis puzzle. Let's explore the spectral analysis puzzle that 3i Atlas has presented to scientists. When astronomers break down the light reflected off this cosmic visitor, they're finding patterns that don't match anything we've seen in objects native to our solar system, creating a chemical mystery that's challenging our understanding of cosmic composition. Think about it like this. You're a chef who spent your entire life working with a specific set of ingredients, and suddenly someone hands you a dish with flavors you've never encountered before. That's essentially what astronomers are dealing with when they analyze the spectral signature of 3i Atlas, a cosmic recipe that includes ingredients we can't quite identify. What's particularly intriguing is that some of these spectral signatures hint at materials that simply don't match anything found in our solar systems, potentially revealing a composition that includes elements or compounds not found in our corner of the cosmos. This has led some researchers to speculate that 3I Atlas might be carrying materials formed under conditions very different from those that existed when our solar system formed. Bring clues about the diversity of cosmic environments that we've never been able to observe directly. The shape and structure conundrum now. Let's tackle one of the most puzzling aspects of 3I Atlas, its unusual shape and structure. Based on variations in its brightness as it tumbles through space, scientists have concluded that this cosmic visitor is highly elongated in a way that challenges our understanding of how space objects form and evolve. The cosmic ripple effect. Let's explore how 3I Atlas has created a ripple effect that extends far beyond the scientific community into unexpected corners of human culture and endeavor. When we think about the impact of this cosmic visitor, we tend to focus on the astronomical discoveries and technological innovations it has inspired. But the influence of 3I Atlas has been much more pervasive, touching everything from art and literature to economics and politics in ways that are both subtle and profound. Imagine dropping a stone in a pond and watching the ripples spread outward, touching every part of the water's surface. That's essentially what's happened with 3I. Atlas's discovery has created ripples that have spread through human culture, inspiring creativity, sparking conversations, and even influencing how we think about our future as a species. What's particularly fascinating is watching how these ripples have manifested in different domains. Artists have created works inspired by the mystery of this interstellar visitor. Musicians have composed pieces that capture the wonder and awe of cosmic discovery. Even chefs have developed dishes inspired by the colors and shapes associated with 3I Atlas. It's like watching a cultural ecosystem respond to a new element in its environment, with each part of the ecosystem finding its own way to incorporate and interpret this cosmic mystery, the economic transformation now. Let's dive into the economic transformation that's been quietly unfolding in the wake of 3I Atlas's discovery. Beyond the obvious increases in funding for astronomical research and the boom in telescope sales, this cosmic visitor has been reshaping economic landscapes in ways that few people have noticed. Think about it like this. When gold is discovered in a region, it doesn't just create wealth for miners. It transforms the entire economy, creating new industries, new supply chains, and new opportunities that extend far beyond the gold rush itself. That's essentially what's happening with 3I Atlas. It's created a cosmic gold rush that's generating economic ripples across multiple sectors. What's particularly interesting is how this economic transformation is creating new career paths that didn't exist a few years ago. We've seen the emergence of interstellar object specialists who consort with space agencies and private companies. Cosmic data interpreters who specialize in analyzing the complex information generated by objects like 3I Atlas. Even space tourism planners who are designing experiences around the possibility of future interstellar encounters. It's like watching a new ecosystem of economic activity emerge around a cosmic discovery, creating niches and opportunities that no one could have predicted. The political implications. Let's explore something that doesn't get enough attention. The political implications of 3I Atlas's discovery. In an era of increasing international tension and competition, this cosmic visitor has created opportunities for cooperation that transcend political divisions and national interests. Imagine you're living in a neighborhood where neighbors barely speak to each other, and suddenly a mysterious visitor arrives that everyone wants to understand. That's essentially what's happened on the global stage with 3I Atlas. It has created a shared mystery that has brought countries together in ways that few other issues have managed to achieve in recent years. What's particularly fascinating is watching how this scientific cooperation has created diplomatic opportunities that extend beyond the study of 3I Atlas itself. Researchers who collaborated on studying this cosmic visitor have established relationships that are proving valuable for addressing other global challenges. It's like watching a scientific partnership serve as a bridge between nations, creating channels of communication and trust that can be used for addressing other issues as well. The educational revolution now. Let's dive into the educational revolution that's been quietly unfolding in classrooms and lecture halls around the world. 3I Atlas has proven to be an extraordinary teaching tool, capable of engaging students in ways that traditional astronomical examples simply can't match. Picture this. You're trying to explain complex concepts about orbital mechanics to a classroom of students, and suddenly you have a real-life cosmic mystery that perfectly illustrates these concepts in action. That's essentially what educators have been working with since 3I Atlas's appearance. A teaching tool that brings abstract scientific concepts to life in ways that textbooks never could. What's particularly exciting is how this educational revolution is extending beyond traditional academic settings. Science museums have developed interactive exhibits around 3I Atlas. Planetariums have created shows that explore the mystery of this interstellar visitor. Even online learning platforms have seen surges in enrollment for astronomy and physics. Courses inspired by public interest in 3I Atlas. It's like watching a cosmic mystery serve as a gateway drug for scientific curiosity, inspiring people of all ages to learn more about the universe and our place within it. The cultural resonance. Let's explore the cultural resonance of 3I Atlas, which has proven to be surprisingly deep and multifaceted. This cosmic visitor has tapped into something fundamental in the human psyche, resonating with our innate curiosity about the unknown and our place in the cosmos. Think about it like this. Certain stories or ideas seem to capture the collective imagination in ways that transcend cultural boundaries and historical contexts. These stories often touch on universal human experiences or questions that resonate across different societies and belief systems. That's essentially what's happened with 3I Atlas. It has become a cultural touchstone that speaks to something fundamental about the human experience. What's particularly fascinating is watching how different cultures have interpreted the significance of 3I Atlas through their own unique lenses. Some see it as a spiritual messenger, others as a scientific curiosity, and still others as a symbol of humanity's growing understanding of the cosmos. It's like watching a global Rorschach test, with 3I Atlas serving as a cosmic inkblot that reveals different aspects of human culture, belief, and imagination depending on who's doing the interpreting. The technological spin-off. Let's dive into the technological spin-offs that have emerged from the effort to study 31ATLAS. History has shown that major scientific endeavors often produce technological innovations that extend far beyond their original purpose. And the study of this cosmic visitor has been no exception. Imagine you're trying to develop a special camera to photograph a rare bird that only appears for a few minutes at dawn. And in the process, you invent imaging technology that revolutionizes medical diagnostics. That's essentially what's happened with the technologies developed to study 31ATLAS innovations created to solve specific astronomical challenges, better finding applications across multiple industries. What's particularly exciting is how these technological spin-offs are creating benefits that extend far beyond the scientific community. The advanced image processing techniques developed to enhance our view of 3I Atlas are now being used in medical imaging, helping doctors detect diseases earlier and more accurately. The computational methods created to model the object's trajectory are being adapted for weather prediction and climate modeling. It's like watching a scientific investment pay dividends across multiple sectors of the economy and society. The philosophical reawakening. Let's explore the philosophical reawakening that's been quietly unfolding in academic departments and intellectual circles around the world. 31ATLAS has forced philosophers to reconsider some of the most fundamental questions about human existence, consciousness, and our place in the cosmos. Picture this. You're a philosopher who spent your career grappling with questions about human significance and meaning. And suddenly you're confronted with evidence that we might be part of a much larger cosmic community than we ever imagined. That's essentially what's happened to philosophers around the world with the discovery of 31ATLAS. It has created new contexts for age-old questions about who we are and what our purpose might be. What's particularly fascinating is watching how different philosophical traditions are responding to the implications of 3I Atlas. Eastern philosophical traditions, with their emphasis on interconnectedness and cosmic unity, find validation in the idea that we are part of a larger cosmic ecosystem. Western philosophical traditions, with their focus on rational inquiry and empirical evidence, are challenged to incorporate new possibilities that stretch the boundaries of what we consider knowable. It's like watching a global philosophical conversation unfold in real time, with 3I Atlas serving as a catalyst for re-examining some of humanity's most fundamental questions. The creative inspiration now. Let's dive into the wave of creative inspiration that 3I Atlas has unleashed across the artistic community. From painters and sculptors to writers and musicians, artists around the world have found in this cosmic visitor a muse that speaks to something deep and universal in human creativity. Think about it like this. Throughout history, certain discoveries or events have captured the artistic imagination in ways that transcend their scientific or historical significance. These moments become cultural touchstones that inspire creative expression across multiple artistic disciplines. That's essentially what's happened with 3I Atlas. It has become a source of inspiration that's resonating with artists working in every medium imaginable. The Cosmic Detective Agency, International Editionettes, zoom in on one of the most remarkable aspects of the Three-Eye Atlas. Phenomena, the International Detective Agency that sprang into action almost overnight. When this cosmic visitor first appeared on astronomical radar, it triggered what can only be described as a global scientific mobilization, the likes of which we've rarely seen in the history of astronomy. Picture this: phones ringing in observatories from Chile to China, from Australia to Arizona at all hours of the day and night. Scientists who'd been competing for research funding and telescope time suddenly found themselves working together, sharing data in real time and coordinating observations across time zones like a well-oiled machine. It was like watching a cosmic version of the United Nations spring into existence, but with a singular focus on understanding this mysterious visitor. What made this collaboration particularly extraordinary was how it transcended not just geographical boundaries, but political ones as well, in an era when international tensions often dominate headlines. 3180 LAS created a scientific bridge between nations that typically have limited cooperation. American astronomers worked alongside Iranian researchers, Chinese scientists shared data with Indian colleagues. It was as if this cosmic visitor had reminded everyone that when it comes to the big questions about our place in the universe, we're all on the same team. The technological arms race, Cosmic Edition now. Let's talk about the technological arms race that 3-Eye ATLAS has kicked off in the astronomical community. This isn't about weapons or military superiority, it's about who can develop the best tools to detect, track, and study the next interstellar visitor that passes through our cosmic neighborhood. Imagine you're in a gold rush, and everyone's racing to develop better mining equipment to extract the most gold. That's essentially what's happening in the scientific community, but instead of gold, everyone's racing to extract the most data and understanding from interstellar objects. The result has been a technological innovation cycle that's pushing the boundaries of what's possible in astronomical observation and analysis. What's particularly exciting is how this technological push is creating benefits that extend far beyond the study of interstellar objects. The advanced sensors developed to detect objects like 3180LAS are improving our ability to track potentially dangerous asteroids. The image processing techniques created to enhance our view of distant cosmic visitors are helping us get clearer images of exoplanets. It's like inventing a new type of fishing net to catch a specific rare fish, only to discover that it works even better for catching all sorts of other sea creatures you didn't even know were there. The data tsunami. Riding the wave, let's dive into the data tsunami that 3-Eye Atlas has created for scientists. We're not talking about a few spreadsheets and some grainy photos here. We're talking about a deluge of information that would make your laptop cry for mercy, and your internet provider consider a career change. Picture this: every telescope that tracked 3-Eye ATLAS produced terabytes of data. Every spectroscopic analysis generated complex spectral signatures that needed interpretation. Every observation created new questions that required additional data to answer. The result was a feedback loop of data generation that's keeping scientists busy for years, if not decades. What's particularly fascinating is how this data challenge has transformed the way astronomical research is conducted. Traditional approaches, where individual researchers or small teams work with limited data sets, have been replaced by massive collaborative efforts involving hundreds of scientists across multiple institutions. It's like watching the evolution from cottage industries to global corporations, but happening in the realm of scientific research over a period of months rather than centuries. The computational challenge, crunching cosmic numbers now. Let's explore the computational nightmare that 3i Atlas has created for scientists. The object's unusual characteristics and behavior have pushed existing computer models to their breaking point, forcing researchers to develop entirely new ways of simulating and analyzing interstellar phenomena. Imagine you're trying to predict the path of a moving object, but it doesn't follow any of the rules you've programmed into your simulation. That's essentially what scientists have been dealing with when trying to model 3i Atlas's trajectory and behavior. Using existing computational tools, the result has been a crash course in computational innovation that's pushing the boundaries of what's possible with current technology. What's particularly interesting is how this computational challenge has led to collaborations between astronomers and computer scientists that might never have happened otherwise. It's like watching two different specialties discover they speak the same language, creating partnerships that are advancing both fields in unexpected ways. The algorithms and modeling techniques developed to understand 3i Atlas are already finding applications in everything from climate modeling to financial forecasting. The theoretical revolution, rewriting the cosmic rulebook. Let's dive into the theoretical revolution that 3i Atlas has sparked in the scientific community. When this cosmic visitor appeared, it didn't just challenge our observational capabilities, it blew the doors off our theoretical understanding of interstellar objects, forcing scientists to reconsider some of their most fundamental assumptions about the cosmos. Picture this. You're a physicist who's spent your entire career developing theories about how objects move through space, and suddenly an object comes along that seems to break all the rules you thought were unbreakable. That's essentially what happened to the astronomical community when 3i Atlas made its appearance, forcing a complete rethinking of our understanding of interstellar dynamics. What's particularly fascinating is watching how different scientific disciplines are contributing to this theoretical revolution. Physicists, chemists, engineers, and even biologists are all weighing in with their perspectives, creating a multidisciplinary approach to understanding 3i Atlas that's as innovative as it is comprehensive. It's like watching a scientific dream team tackle a problem that's too complex for any single discipline to solve alone. The spectroscopic puzzle, decoding cosmic chemistry now. Let's explore the spectroscopic puzzle that 3i Atlas has presented to scientists. When astronomers break down the light reflected off this cosmic visitor, they're finding patterns that don't match anything we've seen in objects native to our solar system, creating a chemical mystery that's challenging our understanding of cosmic composition. Think about it like this. You're a chef who's spent your entire life working with a specific set of species, and suddenly someone hands you a dish with flavors you've never encountered before. That's essentially what astronomers are dealing with when they analyze the spectral signature of 3i Atlas, a cosmic recipe that includes ingredients we can't quite identify. What's particularly intriguing is that some of these spectral signatures hint at materials that simply don't match anything found in our solar system, potentially revealing a composition that includes elements or compounds not found in our corner of the cosmos. This has led some researchers to speculate that 3I Atlas might be carrying materials formed under conditions very different from those that existed when our solar system formed, offering clues about the diversity of cosmic environments that we've never been able to observe directly: the shape, enigma, cosmic sculpture, or space rock. Let's tackle one of the most puzzling aspects of 3I Atlas, its unusual shape. Based on variations in its brightness as it tumbles through space, scientists have concluded that this cosmic visitor is highly elongated in a way that challenges our understanding of how space objects form and evolve. Picture this: you're a geologist who's spent your career studying rocks, and suddenly you're shown a stone that seems to defy the natural processes create geological formations. That's essentially what astronomers are dealing with when they consider the shape of 31ATL, an object that doesn't fit neatly into our existing categories of space objects. What's particularly fascinating is how this shape conundrum has led to some intriguing debates about whether 3I Atlas might be artificial rather than natural. While most scientists favor natural explanations, the object's unusual form factor has forced even mainstream researchers to consider possibilities that would normally be relegated to the realm of science fiction. It's like finding a tool in the desert that's so perfectly designed for its purpose that you can't help but wonder if it was made by intelligent hands, even though all evidence suggests it's a natural formation. The velocity mystery. Cosmic speed demon now. Let's dive into the velocity mystery that makes 3I Atlas so extraordinary. This cosmic visitor moves through our solar system at speeds that exceed what we'd typically expect for an object passing through our celestial neighborhood, creating a kinetic puzzle that has scientists scratching their heads. Imagine you're watching a vehicle pass through your neighborhood at speeds that seem impossible for the type of vehicle it appears to be, moving faster than it should be able to based on its apparent propulsion system. That's essentially what astronomers are observing with 3I Atlas, an object that's moving through space with a velocity that challenges our understanding of interstellar dynamics. The Cosmic Neighborhood Watch. Expanding our horizons, let's zoom out and consider how 3I Atlas has essentially forced humanity to establish what you might call a cosmic neighborhood watch. For decades, we've been focused on monitoring potential threats from within our solar system: asteroids, comets, and other objects that might pose a danger to Earth. But 31 Atlas has reminded us that we need to be watching the cosmic highways beyond our celestial borders as well. Imagine you've installed a security system to monitor your property, only to realize that you've been ignoring the street outside your gate, where all sorts of interesting and potentially significant activity has been happening unnoticed. That's essentially what the astronomical community discovered with 3I Atlas. We've been so focused on local threats that we've barely been paying attention to the cosmic traffic passing through our neighborhood. What's particularly fascinating is how this expanded monitoring is revealing that our solar system might be much busier than we ever imagined. Each new detection system we deploy seems to uncover additional objects passing through our celestial neighborhood, suggesting that we're living in a cosmic metropolis with visitors coming and going in ways we're only beginning to understand. It's like installing security cameras around your home and discovering that your street is actually a major thoroughfare you never knew existed. The interstellar material transfer theory. Cosmic panspermia now. Let's dive into a theory that's gaining traction among scientists. The idea that objects like 3I Atlas might be playing a crucial role in transferring materials between star systems. This concept, sometimes called interstellar panspermia, suggests that cosmic visitors might be carrying organic compounds, microbes, or even the building blocks of life from one star system to another. Picture this. You're a gardener who's always wondered why certain plants keep appearing in your garden. And then you realize that birds are carrying seeds from neighboring yards. That's essentially what some scientists believe might be happening on a cosmic scale. Interstellar objects like 3I Atlas might be cosmic delivery services, transporting materials between star systems in ways that could influence the development of life across the galaxy. What's particularly mind-boggling is the implication that if this theory is correct, life on Earth might not be entirely homegrown after all. We could be part of a cosmic ecosystem that's been exchanging materials and potentially even life forms for billions of years. It's like discovering that your family tree extends far beyond your immediate relatives to include branches you never knew existed, connecting you to a much larger community than you ever imagined. The gravitational signature mystery. Defying physics lets explore something that has physicists scratching their heads. The unusual gravitational signature of 3I Atlas. As this cosmic visitor passed through our solar system, it didn't move exactly as expected based on gravitational calculations alone, leading some researchers to wonder if there might be additional forces at play. Imagine you're watching a ball roll down a hill, and it suddenly changes speed or direction without any apparent cause. That's essentially what astronomers observed with 3I Atlas. Subtle deviations in its trajectory that don't quite match what we'd expect based on our understanding of gravitational interactions. What's particularly intriguing is that these gravitational anomalies have led to some fascinating and highly speculative theories about whether 3I Atlas might have some form of propulsion system, or whether it might be interacting with gravitational fields in ways we don't yet understand. While most scientists attribute these anomalies to observational limitations or calculation errors, a minority argued that they might hint at physics beyond our current understanding. It's like watching a magician perform a trick that seems to defy the laws of nature. You know there must be a rational explanation, but you can't quite figure out what it is. The cosmic time capsule concept, messages from the past. Now, let's consider a truly fascinating idea that 3I Atlas might be serving as a cosmic time capsule, carrying information about conditions in other parts of the universe from billions of years ago. If this object has indeed been traveling through interstellar space for eons, it could be preserving a snapshot of cosmic conditions that existed when the universe was significantly younger. Think about it like this. Imagine you find a letter that was written thousands of years ago and has been perfectly preserved, offering insights into a civilization that disappeared long ago. That's essentially what 3i Atlas might represent: a cosmic messenger carrying information from distant star systems and ancient cosmic times that we can't obtain through any other means. What's particularly exciting is the possibility that this cosmic time capsule might contain materials or isotopes that don't exist in our solar system, offering clues about stellar processes and cosmic devolution that could revolutionize our understanding of how the universe has changed over time. It's like discovering a fossil that contains DNA from species that went extinct millions of years ago. A potential treasure trove of information about cosmic history that could fundamentally change our understanding of the universe. The observation technique revolution. Seeing the unseen. Let's talk about how 3i Atlas has sparked a revolution in observation techniques that extends far beyond the study of interstellar objects. The challenges posed by this cosmic visitor, its speed, distance, and unusual characteristics have forced astronomers to develop entirely new approaches to observing and analyzing celestial phenomena. Picture this. You're a wildlife photographer who's spent your career using the same camera techniques, and suddenly you're asked to photograph a creature that moves too fast for your equipment to capture. That's essentially what happened to astronomers when 3i Atlas appeared. It exposed the limitations of existing observation techniques and forced a rapid innovation cycle that's transforming how we study the cosmos. What's particularly exciting is how these observational innovations are finding applications across multiple fields of astronomy. The advanced tracking systems developed to follow 3i Atlas are now being used to study fast-moving asteroids. The image processing techniques created to enhance our view of this distant object are helping us get clearer images of exoplanets. It's like developing a new type of fishing net to catch a specific rare fish, only to discover that it works even better for catching all sorts of other sea creatures you didn't even know were there. The Interstellar Trajectory Mapping Challenge. Cosmic cartography. And now, let's dive into the computational nightmare that 3i Atlas has created for astronomers, trying to map its trajectory through our solar system. The object's unusual path and speed have pushed existing modeling techniques to their breaking point, forcing researchers to develop entirely new approaches to understanding how interstellar objects move through space. Imagine you're trying to predict the path of a moving vehicle, but it doesn't follow any of the traffic rules you're familiar with, and it keeps changing speed and direction in ways that seem to defy physics. That's essentially what scientists have been dealing with when trying to model 3i Atlas's trajectory, a cosmic puzzle that has challenged our understanding of celestial mechanics. What's particularly fascinating is how this trajectory mapping challenge has led to collaborations between astronomers and experts from fields that rarely interact with space science. Traffic engineers, fluid dynamics specialists, and even weather pattern modelers have all contributed insights that have helped improve our understanding of how 3i Atlas moves through space. It's like watching a scientific dream team tackle a problem that's too complex for any single discipline to solve alone. The spectral analysis puzzle. Decoding cosmic chemistry. Let's explored the spectral analysis puzzle that 3i Atlas has presented to scientists. When astronomers break down the light reflected off this cosmic visitor, they're finding patterns that don't match anything we've seen in objects native to our solar system. creating a chemical mystery that's challenging our understanding of cosmic composition. Think about it like this. You're a chef who's spent your entire life working with a specific set of ingredients, and suddenly someone hands you a dish with flavors you've never encountered before. That's essentially what astronomers are dealing with when they analyze the spectral signature of 31ATLA, a cosmic recipe that includes ingredients we can't quite identify. What's particularly intriguing is that some of these spectral signatures hint at materials that simply don't match anything found in our solar system, potentially revealing a composition that includes elements or compounds not found in our corner of the cosmos. This has led some researchers to speculate that 3I Atlas might be carrying materials formed under conditions very different from those that existed when our solar system formed, offering clues about the diversity of cosmic environments that we've never been able to observe directly. The shape and structure conundrum. Cosmic sculpture now. Let's tackle one of the most puzzling aspects of 3I Atlas, its unusual shape and structure. Based on variations in its brightness as it tumbles through space, scientists have concluded that this cosmic visitor is highly elongated in a way that challenges our understanding of how space objects form and evolve. The cosmic ripple effect. Beyond the telescope, let's explore how 3I Atlas has created a ripple effect that extends far beyond the scientific community into unexpected corners of human culture and endeavor. When we think about the impact of this cosmic visitor, we tend to focus on the astronomical discoveries and technological innovations it has inspired. But the influence of 3I Atlas has been much more pervasive, touching everything from art and literature to economics and politics in ways that are both subtle and profound. Imagine dropping a stone in a pond and watching the ripples spread outwards, touching every part of the water's surface. That's essentially what's happened with 3I Atlas. Its discovery has created ripples that have spread through human culture, inspiring creativity, sparking conversations, and even influencing how we think about our future as a species. What's particularly fascinating is watching how these ripples have manifested in different domains. Artists have created works inspired by the mystery of this interstellar visitor. Musicians have composed pieces that capture the wonder and awe of cosmic discovery. Even chefs have developed dishes inspired by the colors and shapes associated with 3I Atlas. It's like watching a cultural ecosystem respond to a new element in its environment, with each part of the ecosystem finding its own way to incorporate and interpret this cosmic mystery. The economic transformation. Cosmic gold rush now. Let's dive into the economic transformation that's been quietly unfolding in the wake of 3I Atlas's discovery. Beyond the obvious increases in funding for astronomical research and the boom in telescope sales, this cosmic visitor has been reshaping economic landscapes in ways that few people have noticed. Think about it like this. When gold is discovered in a region, it doesn't just create wealth for miners, it transforms the entire economy, creating new industries, new supply chains, and new opportunities that extend far beyond the gold rush itself. That's essentially what's happening with 3I Atlas. It's created a cosmic gold rush that's generating economic ripples across multiple sectors. What's particularly interesting is how this economic transformation is creating new career paths that didn't exist a few years ago. We're seeing the emergence of interstellar object specialists who consult with space agencies and private companies, cosmic data interpreters who specialize in analyzing the complex information generated by objects like 3I-ATLAS, even space, tourism planners who are designing experiences around the possibility of future interstellar encounters. It's like watching a new ecosystem of economic activity emerge around a cosmic discovery, creating niches and opportunities that no one could have predicted. The political implications, cosmic diplomacy. Let's explore something that doesn't get enough attention: the political implications of 3I-ATLAS's discovery. In an era of increasing international tension and competition, this cosmic visitor has created opportunities for cooperation that transcends political divisions and national interests. Imagine you're living in a neighborhood where neighbors barely speak to each other, and suddenly a mysterious visitor arrives that everyone wants to understand. That's essentially what's happened on the global stage with 3I-ATLAS. It has created a shared mystery that has brought countries together in ways that few other issues have managed to achieve in recent years. What's particularly fascinating is watching how this scientific cooperation has created diplomatic opportunities that extend beyond the study of 3I-ATLAS itself. Researchers who collaborated on studying this cosmic visitor have established relationships that are proving valuable for addressing other global challenges. It's like watching a scientific partnership serve as a bridge between nations, creating channels of communication and trust that can be used for addressing other issues as well. The educational revolution. Cosmic classroom. Now let's dive into the educational revolution that's been quietly unfolding in classrooms and lecture halls. Around the world, 3I-ATLAS has proven to be an extraordinary teaching tool, capable of engaging students in ways that traditional astronomical examples simply can't match. Picture this. You're trying to explain complex concepts about orbital mechanics to a classroom of students, and suddenly you have a real-life cosmic mystery that perfectly illustrates these concepts in action. That's essentially what educators have been working with since 3I-ATLAS's appearance, a teaching tool that brings abstract scientific concepts to life in ways that textbooks never could. What's particularly exciting is how this educational revolution is extending beyond traditional academic settings. Science museums have developed interactive exhibits around 3I-ATLAS. Planetariums have created shows that explore the mystery of this interstellar visitor. Even online learning platforms have seen surges in enrollment for astronomy and physics. Courses inspired by public interest in 3I-ATLAS. It's like watching a cosmic mystery serve as a gateway drug for scientific curiosity, inspiring people of all ages to learn more about the universe and our place within it. The cultural resonance. Global Rorschach testlets explore the cultural resonance of 3I-ATLAS, which has proven to be surprisingly deep and multifaceted. This cosmic visitor has tapped into something fundamental in the human psyche, resonating with our innate curiosity about the unknown and our place in the cosmos. Think about it like this. Certain stories or ideas seem to capture the collective imagination in ways that transcend cultural boundaries and historical contexts. These stories often touch on universal human experiences or questions that resonate across different societies and belief systems. That's essentially what's happened with 3i-ATLs. It has become a cultural touchstone that speaks to something fundamental about the human experience. What's particularly fascinating is watching how different cultures have interpreted the significance of 3i Atlas through their own unique lenses. Some see it as a spiritual messenger, others as a scientific curiosity, and still others as a symbol of humanity's growing understanding of the cosmos. It's like watching a global Rorschach test, with 3i-ATLAS serving as a cosmic inkblot that reveals different aspects of human culture, belief, and imagination depending on who's doing the interpreting. The technological spin-offs, unexpected benefits now. Let's dive into the technological spin-offs that have emerged from the effort to study 3i-ATLAS. History has shown that major scientific endeavors often produce technological innovations that extend far beyond their original purpose. And the study of this cosmic visitor has been no exception. Imagine you're trying to develop a special camera to photograph a rare bird that only appears for a few minutes at dawn, and in the process you invent imaging technology that revolutionizes medical diagnostics. That's essentially what's happened with the technologies developed to study 3i-ATLAS. Innovations created to solve specific astronomical challenges that are finding applications across multiple industries. What's particularly exciting is how these technological spin-offs are creating benefits that extend far beyond the scientific community. The advanced image processing techniques developed to enhance our view of 3i-Atlas are now being used in medical imaging, helping doctors detect diseases earlier and more accurately. The computational methods created to model the object's trajectory are being adapted for weather prediction and climate modeling. It's like watching a scientific investment paid dividends across multiple sectors of the economy and society. The philosophical reawakening. Cosmic Questions lets explore the philosophical reawakening that's been quietly unfolding in academic departments and intellectual circles around the world. 3i-ATLAS has forced philosophers to reconsider some of the most fundamental questions about human existence, consciousness, and our place in the cosmos. Picture this: you're a philosopher who spent your career grappling with questions about human significance and meaning, and suddenly you're confronted with evidence that we might be part of a much larger cosmic community than we ever imagined. That's essentially what's happened to philosophers around the world with the discovery of 3i-ATLAS. It has created new contexts for age-old questions about who we are and what our purpose might be. What's particularly fascinating is watching how different philosophical traditions are responding to the implications of 3i-Atlas. Eastern philosophical traditions, with their emphasis on interconnectedness and cosmic unity, find validation in the idea that we're part of a larger cosmic ecosystem. Western philosophical traditions, with their focus on rational inquiry and empirical evidence, are challenged to incorporate new possibilities that stretch the boundaries of what we consider knowable. It's like watching a global philosophical conversation unfold in real time, with 3i-ATLAS serving as a catalyst for re-examining some of humanity's most fundamental questions. The creative inspiration, artistic muse now. Let's dive into the wave of creative inspiration that 3IATLAS has unleashed across the artistic community. From painters and sculptors to writers and musicians, artists around the world have found in this cosmic visitor a muse that speaks to something deep and universal. In human creativity, the Cosmic Detective Agency Advanced Edition lets zoom in on one of the most remarkable aspects of the 3I Atlas phenomenon, the Advanced Detective Agency that has evolved from the initial scientific mobilization. What began as an emergency response to an unexpected cosmic visitor has transformed into a sophisticated, permanent network of researchers, institutions, and technologies dedicated to understanding interstellar phenomena. Picture this. What started as a makeshift command center in a university basement has evolved into something resembling the cosmic version of a high-tech intelligence agency. With analysts working around the clock, data streaming in from observatories worldwide, and artificial intelligence systems sifting through petabytes of information, looking for patterns that humans might miss. It's like watching the birth of a new scientific discipline in real time. What's particularly fascinating is how this detective agency has developed its own specialized divisions. There's the trajectory team, which calculates where objects like 3I Atlas have come from and where they're going. There's the composition squad, which analyzes the chemical makeup of interstellar visitors. There's even the theoretical division, which develops new models to explain the unusual characteristics of these cosmic objects. It's like watching a scientific ecosystem evolve, with different species of researchers developing specialized niches to better understand the cosmic environment. The Interstellar Object Classification System, Cosmic Taxonomy now. Let's dive into the classification system that scientists have developed to categorize interstellar objects like 3IATLAS. When this cosmic visitor first appeared, researchers realized they had no framework for understanding or categorizing objects that come from beyond our solar system. This realization sparked a taxonomic revolution that's changing how we think about celestial objects. Imagine you're a biologist who discovers a new form of life that doesn't fit into any existing category of living things. That's essentially what astronomers faced with 3IATLAS, an object that defied conventional classification systems. The result has been the development of an entirely new taxonomy for interstellar objects, complete with categories, subcategories, and classification criteria that didn't exist a few years ago. What's particularly interesting is how this classification system has revealed patterns and relationships that weren't apparent before. By organizing interstellar objects according to their characteristics, scientists have begun to identify families of objects with similar properties, suggesting that there might be processes or environments that create similar types of interstellar visitors. It's like watching biologists develop the periodic table for the first time, suddenly revealing patterns and relationships that transform our understanding of the cosmic ecosystem. The Interstellar Object Database. Cosmic Library. Let's explore the Interstellar Object Database that has emerged from the study of 3IATLAS. What began as a collection of observations and measurements related to a single cosmic visitor has evolved into a comprehensive repository of information about interstellar objects that's becoming an invaluable resource for researchers worldwide. Think about it like this. Imagine you're building a library, but instead of books, you're collecting data about objects from beyond our solar system. That's essentially what scientists have created with the Interstellar Object Database, a cosmic library that contains information about the shape, composition, trajectory, and characteristics of every interstellar object we've detected. What's particularly exciting is how this database is enabling new types of research that weren't possible before. Scientists can now identify patterns across multiple interstellar objects, compare their characteristics, and develop theories about the processes that create them. It's like having a catalog of products from a cosmic factory we've never seen, offering clues about the manufacturing processes and materials used in other parts of the galaxy. The Interstellar Object Simulation Laboratory, Virtual Cosmos. Now, let's dive into the simulation laboratory that has emerged from the effort to understand 31ATLAS. The challenges posed by this cosmic visitor have led to the development of sophisticated computer models that simulate the formation, evolution, and behavior of interstellar objects, creating a virtual cosmos where researchers can test theories and explore scenarios that would be impossible to study directly. Picture this. You're trying to understand how something works, but you can't take it apart or examine it up close. So you create a computer simulation that allows you to model its behavior under different conditions. That's essentially what scientists have done with interstellar objects. They've created a virtual laboratory where they can explore the physics and chemistry of these cosmic visitors in ways that would be impossible through direct observation alone. What's particularly fascinating is how these simulations are revealing insights that extend beyond interstellar objects themselves. By modeling the processes that create and shape objects like 3I Atlas, scientists are gaining new understanding of stellar evolution, planetary formation, and even the dynamics of entire galaxies. It's like studying a single grain of sand and not learning about the beach, the ocean, and the geological processes that shaped them all. The Interstellar Object Detection Network, Cosmic Watchtower lets explore the detection network that has emerged in the wake of 3IATLAS's discovery. What began as a handful of observatories pointing their telescopes at a single cosmic visitor has evolved into a global network of detection systems, working together to identify and track interstellar objects as they pass through our solar system. Imagine you're trying to create a security system for your neighborhood, but instead of just monitoring the streets, you're watching the entire sky for visitors from beyond your city. That's essentially what scientists have built with the Interstellar Object Detection Network, a cosmic watchtower system that spans the globe and extends into space, with instruments on Earth, in orbit, and even on other planets, all working together to monitor our cosmic neighborhood. What's particularly impressive is how this network has transformed our understanding of how busy our solar system actually is. Before 3IATLAS, we thought interstellar visitors were rare events. Now, with a detection network in place, we're realizing that objects from beyond our solar system pass through more frequently than we ever imagined. We just didn't have the right systems in place to notice them before. It's like installing security cameras and discovering that your quiet street is actually a major thoroughfare you never knew existed. The Interstellar Object Sample Return Mission, Cosmic Treasure Hunt now. Let's dive into one of the most ambitious projects to emerge from the study of 3I-ATLAS. The proposed sample return mission that would attempt to collect material from an interstellar object and bring it back to Earth for analysis. This mission, which is still in the planning stages, represents one of the most challenging and potentially rewarding endeavors in the history of space exploration. Think about it like this. Imagine you're an archaeologist who hears about a mysterious artifact from a lost civilization, but it's in a location that's incredibly difficult to reach. That's essentially what scientists are proposing with the Interstellar Object Sample Return Mission, an attempt to retrieve a piece of something from beyond our solar system, a cosmic artifact that could revolutionize our understanding of the universe. What's particularly exciting is how this mission is pushing the boundaries of space technology. To intercept an interstellar object, collect a sample, and return it to Earth would require advances in propulsion systems, navigation, autonomous operations, and sample collection techniques that don't currently exist. It's like watching the Apollo program unfold in miniature, with each technological challenge spawning innovations that will benefit space exploration for decades to come. The Interstellar Object Communication Protocol, Cosmic Language. Let's explore the communication protocol that scientists have developed for sharing information about interstellar objects. When 3I-ATLAS appeared, researchers realized they had no standardized way to share data about this cosmic visitor, leading to confusion and inefficiencies as different teams used different formats and conventions. This realization sparked the development of a universal communication protocol for interstellar object research. Picture this. You're trying to coordinate a global response to a rapidly evolving situation, but everyone is speaking different languages and using different measurement systems. That's essentially what scientists faced when they first tried to share information about 3I-ATLAS. The solution has been the development of a standardized protocol that allows researchers worldwide to communicate seamlessly about interstellar objects. What's particularly interesting is how this communication protocol has facilitated collaborations that might never have happened otherwise. By creating a common language for discussing interstellar objects, scientists from different countries, different institutions, and even different disciplines can now work together more effectively. It's like watching the development of a new scientific language, one that's specifically designed to help humanity understand its place in the cosmos. The Interstellar Object Research Consortium Global Brain Trust. Let's explore how the study of 3I-ATLAS has evolved into a permanent global research consortium that represents one of the most ambitious scientific collaborations in human history. What began as an emergency response to an unexpected cosmic visitor has transformed into a sophisticated international organization dedicated to understanding interstellar phenomena. Picture this. Imagine the world's leading space agencies, research institutions, and universities all working together under a unified framework, sharing data, resources, and expertise in real time. That's essentially what the Interstellar Object Research Consortium has become, a global brain trust that brings together the best minds from every continent to tackle questions that are too big and complex for any single institution or country to handle alone. What's particularly remarkable is how this consortium has developed its own governance structure, research priorities, and funding mechanisms that transcend national interests. There are working groups focused on specific aspects of interstellar object research, from detection and tracking to composition, analysis, and theoretical modeling. It's like watching the formation of a new type of scientific organization, one that's designed to address truly global challenges that extend beyond earthly boundaries and concerns. The Interstellar Object Technology Transfer Program, Cosmic Innovation. Let's dive into the technology transfer program that has emerged from the study of three IATLAS. The technologies developed to detect, track, and analyze this cosmic visitor have proven to have applications far beyond astronomy, creating a ripple effect of innovation that's transforming multiple industries. Think about it like this. Imagine you develop a special camera to photograph a rare bird that only appears for a few minutes at dawn. And in the process, you invent imaging technology that revolutionizes medical diagnostics, manufacturing quality control, and even art restoration. That's essentially what's happened with the technologies developed to study 31ATLAS innovations created to solve specific astronomical challenges that are finding applications across multiple sectors of the economy. What's particularly exciting is how this technology transfer program is creating benefits that extend far beyond the scientific community. The advanced sensors developed to detect interstellar objects are improving early warning systems for natural disasters. The image processing techniques created to enhance our view of distant cosmic visitors are helping doctors detect diseases earlier and more accurately. The computational methods developed to model interstellar trajectories are being adapted for climate modeling and financial forecasting. It's like watching a scientific investment pay dividends across society. With innovations originally designed for understanding the cosmos, improving life here on Earth, the Interstellar Object Citizen Science Network, Cosmic Crowdsource Let's explore the Citizen Science Network that has emerged from the study of 3I-ATLAS, recognizing that the volume of data generated by interstellar object research is too vast for professional scientists to analyze alone. Researchers have developed platforms that allow ordinary people to contribute to the discovery and analysis of these cosmic visitors. Picture this. Imagine you have millions of photographs of the sky, and you need to identify objects that might be interstellar visitors. You could try to develop artificial intelligence to do this, but you realize that human eyes are often better at spotting unusual patterns. That's essentially what scientists have done with the Citizen Science Network. They've created platforms that allow anyone with an internet connection to contribute to real astronomical research. What's particularly fascinating is how this Citizen Science Network has discovered things that professional researchers might have missed. Amateur astronomers have spotted interstellar objects that automated systems failed to detect. Students have identified patterns in data that experienced researchers overlooked. Even retirees have made significant contributions by dedicating their free time to analyzing astronomical data. It's like watching a global community form around a shared scientific quest, with everyone from elementary school students to great-grandparents finding ways to contribute to our understanding of the cosmos. The interstellar object virtual reality. Experience cosmic immersion now. 8. Dive into the virtual reality experience that has emerged from the study of 3I Atlas. Recognizing that most people will never have the opportunity to visit an observatory or handle astronomical data directly, researchers have collaborated with technology companies to create immersive VR experiences that allow users to explore interstellar objects in ways that were previously impossible. Think about it like this. Imagine you could shrink down to the size of a molecule and fly around an interstellar object, examining its surface, structure, and composition up close. That's essentially what the interstellar object VR experience allows users to do. It creates scientifically accurate simulations of objects, like 3I Atlas, that people can explore using virtual reality technology. What's particularly exciting is how this VR experience is making complex scientific concepts accessible to people who might not engage with traditional educational materials. Instead of reading about the shape of 3I Atlas, users can actually see it for themselves. Instead of trying to understand abstract descriptions of its trajectory, they can follow its path through the solar system in 3 dimensions. It's like watching the boundary between education and entertainment dissolve, creating learning experiences that are as engaging as they are informative. The Interstellar Object documentary series. Cosmic Storytelling lets explore the documentary series that has emerged from the study of 3I Atlas. Recognizing that this cosmic visitor represents a story that's as compelling as it is scientifically significant, researchers have collaborated with filmmakers to create a comprehensive documentary series that explores the discovery, characteristics, and implications of interstellar objects. Picture this. Imagine you're trying to tell the story of one of the most significant astronomical discoveries in human history, and you want to make it accessible to people who don't have a scientific background. That's essentially what filmmakers have done with the Interstellar Object documentary series. They've translated complex scientific concepts into compelling narratives that anyone can understand and appreciate. What's particularly interesting is how this documentary series has approached the story from multiple angles. There are episodes focusing on the scientific discovery of 3I Atlas, episodes exploring the technological innovations it inspired, episodes examining the cultural impact of interstellar objects, and even episodes speculating about what future discoveries might reveal. It's like watching a comprehensive exploration of a topic that touches on every aspect of human experience, from the technical to the philosophical to the emotional. The Interstellar Object Podcast Network. Cosmic Conversations Now. Let's dive into the podcast network that has emerged from the study of 3I Atlas. Recognizing that people consume information in different ways and have different levels of scientific background, researchers have developed a range of podcasts that explore interstellar objects from various perspectives and at different levels of technical detail. Think about it like this. Imagine you want to learn about a complex scientific topic, but you prefer listening to conversations while you're commuting or exercising rather than reading articles or watching videos. That's essentially what the Interstellar Object Podcast Network provides: audio content that allows people to engage with cosmic discoveries wherever they are and whatever they're doing. What's particularly fascinating is how this podcast network has developed shows for different audiences. There are highly technical podcasts for professional astronomers, educational podcasts for students, conversational podcasts for general audiences, and even storytelling podcasts that use interstellar objects as a jumping-off point for exploring broader questions about science and society. It's like watching a media ecosystem develop around a scientific topic, with different formats and approaches designed to meet the needs and interests of diverse audiences. The Interstellar Object video game. Cosmic Adventurelets explore the video game that has emerged from the study of 31ATLAS, recognizing that interactive experiences can be powerful educational tools. Researchers have collaborated with game developers to create a video game that allows players to participate in the discovery and study of interstellar objects. Picture this. Imagine you could be the astronomer who discovers the next interstellar visitor, or the engineer who designs the mission to study it, or even the explorer who travels to it in a virtual spacecraft. That's essentially what the Interstellar Object video game allows players to do. It creates a scientifically accurate simulation of the process of discovering and studying cosmic visitors, allowing players to learn through interactive gameplay. The Interstellar Object Research Vessel, Cosmic Explorerless, explore one of the most ambitious projects to emerge from the study of 3I Atlas. The proposed research vessel specifically designed to study interstellar objects up close. This spacecraft, which represents a quantum leap in our ability to explore cosmic visitors, is currently in the design phase but could revolutionize our understanding of objects from beyond our solar system. Picture this. Imagine a spacecraft that can rapidly change course to intercept newly discovered interstellar objects, approach them safely, and deploy a suite of advanced instruments to analyze their composition, structure, and characteristics in unprecedented detail. That's essentially what the Interstellar Object Research Vessel is designed to be. A cosmic explorer that can transform our understanding of these mysterious visitors from distant points of light into detailed, three-dimensional objects we can study as thoroughly as objects in our own solar system. What's particularly exciting is how this research vessel is pushing the boundaries of space technology. To intercept and study interstellar objects, the spacecraft will need advanced propulsion systems that can change velocity quickly, autonomous navigation systems that can operate without human intervention, and instrument suites that can analyze objects under challenging conditions. It's like watching the development of a new generation of space exploration technology, one that's specifically designed to help humanity become active participants in the cosmic ecosystem rather than just passive observers. The Interstellar Object, Artificial Intelligence System, Cosmic Mind Now. Let's dive into the artificial intelligence system that has emerged from the study of 3IATLAS. The challenges posed by this cosmic visitor, its unusual characteristics, the vast amount of data it generated, and the need to make rapid decisions based on incomplete information, have led to the development of sophisticated AI systems, specifically designed to assist with interstellar object research. Think about it like this. Imagine you're trying to analyze a flood of data from multiple sources, identify patterns that humans might miss, and make predictions about how an object will behave in the future. That's essentially what the Interstellar Object Artificial Intelligence System is designed to do. It's a specialized AI that can process astronomical data at speeds and scales that are simply beyond human capability. What's particularly fascinating is how this AI system is evolving beyond its original purpose. What began as a tool for analyzing data from 3i Atlas has developed into something more like a research partner, capable of generating hypotheses, identifying promising areas for investigation, and even suggesting experiments that humans might not have considered. It's like watching the emergence of a new type of scientific intelligence, one that combines the computational power of machines with the curiosity and creativity of human researchers. The Interstellar Object Quantum Sensor Array. Cosmic detectorlets explore the quantum sensor array that has emerged from the study of 3i Atlas. The limitations of conventional sensing technologies when applied to this cosmic visitor have led researchers to develop a new generation of quantum-based sensors that can detect and analyze interstellar objects with unprecedented sensitivity and precision. Picture this. Imagine you're trying to detect an object that's hundreds of meters long but millions of miles away, moving at speeds that make it difficult to track with conventional instruments. That's essentially the challenge that led to the development of the Interstellar Object Quantum Sensor Array, a system that uses quantum phenomena to detect and measure cosmic visitors in ways that were previously impossible. What's particularly exciting is how this quantum sensor array is opening up new possibilities for astronomical observation. By harnessing the strange properties of quantum mechanics, these sensors can detect gravitational fluctuations, measure magnetic fields, and even analyze the composition of distant objects with a level of detail that was simply unattainable with classical sensing technologies. It's like watching a new generation of astronomical eyes develop, ones that can see the cosmos in ways that revealed previously hidden aspects of cosmic reality. The Interstellar Object Communication System. Cosmic dialogue now. Let's dive into the communication system that has emerged from the study of 3i Atlas. While most scientists believe this cosmic visitor is a natural phenomenon, the possibility that it might be artificial has led researchers to develop systems designed to detect and potentially even communicate with non-terrestrial intelligence. Think about it like this. Imagine you're trying to listen for signals from a civilization that might communicate in ways we can't even imagine, using technologies we haven't invented yet. That's essentially the challenge that led to the development of the Interstellar Object Communication System, a comprehensive approach to detecting and analyzing potential signals from cosmic visitors that goes beyond traditional SETI search for extraterrestrial intelligence methods. What's particularly interesting is how this communication system balances scientific rigor with open-minded speculation. On one hand, it's designed to detect any unusual signals or patterns that might indicate artificial origin or intelligence. On the other hand, it's structured to avoid false positives and to ensure that any potential detections are subjected to rigorous scientific scrutiny before being announced. It's like watching humanity develop its cosmic listening skills, preparing for the possibility that we might one day encounter intelligence from beyond our solar system. The Interstellar Object Ethical Framework, Cosmic Responsibility. Let's explore the ethical framework that has emerged from the study of 3i Atlas. As scientists have learned more about this cosmic visitor, they've realized that interstellar objects raise complex ethical questions that existing frameworks aren't equipped to address. This realization has led to the development of a comprehensive ethical framework for how humanity should interact with objects from beyond our solar system. Picture this. Imagine you're confronted with something that might be a natural phenomenon, or might be an artifact from an alien civilization, and you have to decide how to study it without potentially causing harm or missing an opportunity for contact. That's essentially the ethical challenge that interstellar objects present, and the ethical framework is an attempt to provide guidance for these unprecedented situations. What's particularly fascinating is how this ethical framework is balancing scientific curiosity with caution and responsibility. It addresses questions like, how should we study interstellar objects to maximize scientific knowledge while minimizing potential risks? What are our obligations if we discover that an object is artificial rather than natural? How should we share information about interstellar objects with the public while avoiding unnecessary panic or speculation? It's like watching humanity develop its cosmic conscience, figuring out how to be responsible explorers in a universe that's suddenly become much more complex and mysterious than we thought. The Interstellar Object International Treaty, Cosmic. Now, let's dive into the international treaty that has emerged from the study of 3 IATLAS, recognizing that interstellar objects don't respect national boundaries and that their study requires global cooperation. Researchers have worked with diplomats and policymakers to develop an international framework for how countries should collaborate on the detection, study, and potential response to these cosmic visitors. Think about it like this. Imagine you're trying to create rules for how countries should work together to study something that passes through multiple national jurisdictions and doesn't belong to any single nation. That's essentially the challenge that led to the development of the Interstellar Object International Treaty, a legal framework that ensures cooperation rather than competition. When it comes to studying these cosmic visitors, what's particularly significant is how this treaty represents a new model for international scientific cooperation. Unlike previous space treaties, which focus primarily on territorial claims and military uses of space, the Interstellar Object Treaty is specifically designed to facilitate peaceful scientific collaboration and ensure that the benefits of studying interstellar objects are shared by all humanity. It's like watching the development of a new type of international law, one that's designed to address challenges that extend beyond national interests to the collective good of all humanity. The Interstellar Object Cultural Exchange Program, Cosmic Bridge. Let's explore the cultural exchange program that has emerged from the study of 3-1-ATLAS. Recognizing that this cosmic visitor has captured the imagination of people around the world, researchers have developed a program that uses interstellar objects as a bridge between different cultures, creating opportunities for collaboration and understanding that transcend national and cultural boundaries. Picture this. Imagine you have a topic that's fascinating to people in every country, regardless of their language, religion, or political system. That's essentially what interstellar objects have become. And the Cultural Exchange Program is designed to leverage this universal interests to create connections between people who might otherwise have little in common. The Interstellar Object Quantum Computing Initiative. Cosmic Calculation. Let's explore the quantum computing initiative that has emerged from the study of 3 The computational challenges posed by this cosmic visitor, modeling its trajectory, analyzing its composition, and simulating its behavior have pushed classical computing to its limits, inspiring researchers to develop quantum computing approaches specifically designed for interstellar object research. Picture this. Imagine you're trying to calculate the path of an object that's been traveling through space for millions of years, influenced by the gravitational fields of countless stars and planets, and you need to account for quantum effects that might affect its trajectory. That's essentially the computational challenge that led to the Interstellar Object Quantum Computing Initiative, an effort to harness the strange properties of quantum mechanics to solve problems that are intractable with classical computers. What's particularly exciting is how this quantum computing initiative is opening up new possibilities for scientific research. By using quantum bits instead of classical bits, these computers can process multiple possibilities simultaneously, allowing researchers to explore scenarios and solutions that would be impossible with conventional computing. It's like watching a new form of computational intelligence emerge, one that can think in ways that are fundamentally different from human minds or classical computers, potentially revealing insights about the cosmos that were previously beyond our reach. The Interstellar Object Nanotechnology Probe, Cosmic Microscope. Now, let's dive into the nanotechnology probe that has emerged from the study of 3 the limitations of conventional spacecraft when it comes to studying interstellar objects up close have inspired researchers to develop microscopic probes that can be deployed in swarms to analyze these cosmic visitors in unprecedented detail. Think about it like this. Imagine you could send thousands of microscopic robots to study an interstellar object, each one equipped with specialized sensors to analyze different aspects of its composition, structure, and behavior. That's essentially what the Interstellar Object Nanotechnology Probe is designed to be, a swarm of tiny explorers that can collectively gather more information than a single larger spacecraft ever could. What's particularly fascinating is how these nanoprobes are designed to work together as a coordinated system. Each individual probe has limited capabilities, but when they communicate and collaborate, they form a distributed sensing network. They can create a comprehensive picture of an interstellar object. It's like watching a new form of exploration. Technology emerge, one that mimics natural systems like ant colonies or immune systems to create something that's more than the sum of its parts. The Interstellar Object Time Capsule Project. Cosmic Message. Let's explore the time capsule project that has emerged from the study of 3 inspired by the possibility that this cosmic visitor might be carrying information from distant star systems or ancient cosmic times. Researchers have developed a project to create time capsules that could potentially be intercepted by interstellar objects or carried by them to other parts of the galaxy. Picture this. Imagine you could send a message to the stars, one that might be discovered by alien civilizations millions of years from now, or that might be carried by cosmic visitors to parts of the universe we can't even imagine. That's essentially what the Interstellar Object Time Capsule project is designed to do. It's humanity's attempt to participate in the cosmic conversation, to send something of ourselves out into the vastness of space. What's particularly thought-provoking is how this project has forced us to consider what we would want to say to unknown cosmic neighbors. How we would represent humanity and Earth to beings who might have no context for understanding our world. The time capsules include scientific information about Earth and humanity, artistic expressions of human culture, and even recordings of the sounds of our planet. It's like watching humanity prepare its cosmic introduction, deciding what aspects of ourselves we want to share with a universe that might be listening. The Interstellar Object Virtual Observatory. Cosmic Window now. Let's dive into the virtual observatory that has emerged from the study of 3i Atlas, recognizing that most people will never have the opportunity to visit a real observatory or use professional astronomical equipment. Researchers have developed a virtual observatory that allows anyone with an internet connection to explore the cosmos and even participate in real astronomical research. Think about it like this. Imagine you could control a powerful telescope located on a mountain in Chile, point it at any object in the sky, and analyze the data you collect using professional-grade software, all from your computer or smartphone. That's essentially what the Interstellar Object Virtual Observatory provides, a window to the cosmos that's accessible to everyone, regardless of their location or resources. What's particularly exciting is how this virtual observatory is democratizing astronomical research. Instead of being limited to professional astronomers with access to expensive equipment, anyone can contribute to real scientific discoveries. From identifying potential interstellar objects to analyzing their characteristics, it's like watching the boundary between professional science and public participation dissolve, creating a more inclusive and collaborative approach to cosmic exploration that invites everyone to be part of the discovery process. The Interstellar Object Sensory Experience. Cosmic perception lets explore the sensory experience that has emerged from the study of 3i Atlas. Recognizing that most of our understanding of interstellar objects comes through visual data, researchers have developed ways to translate astronomical information into other sensory modalities, allowing people to experience cosmic phenomena through sound, touch, and even smell. Picture this. Imagine you could listen to the music of an interstellar object with different aspects of its composition and structure translated into different sounds and rhythms. Or imagine you could feel the texture of its surface through haptic feedback, or even smell the chemical compounds that make up its composition. That's essentially what the interstellar object sensory experience offers: new ways of perceiving cosmic phenomena that go beyond traditional visual representations. What's particularly fascinating is how these sensory experiences are revealing aspects of interstellar objects that weren't apparent through visual data alone. By translating astronomical information into different sensory modalities, researchers are discovering patterns and relationships that might have been missed when looking at images or graphs. It's like watching our understanding of the cosmos expand through the development of new ways of perceiving it, creating a more rich and nuanced appreciation of cosmic phenomena. The Interstellar Object Dream Research Project. cosmic subconscious now. Let's dive into the DREAM research project that has emerged from the study of 3 IATLAS, recognizing that interstellar objects have captured the public imagination in ways that typical scientific discoveries rarely do. Researchers have developed a project to study how these cosmic visitors are appearing in people's dreams and what this might reveal about our collective relationship with the cosmos. Think about it like this. Imagine you could collect and analyze thousands of dreams from people around the world about interstellar objects, looking for patterns, symbols, and themes that might reveal something about our collective subconscious relationship with the cosmos. That's essentially what the Interstellar Object Dreams research project is designed to do. It's an attempt to understand how cosmic discoveries are working their way into our deepest thoughts and unconscious minds. What's particularly intriguing is how this project is revealing universal themes and symbols that appear across cultures and geographic boundaries. Whether people are in North America, Africa, Asia, or Europe, their dreams about interstellar objects often contain similar elements: feelings of wonder, encounters with unknown beings, journeys through vast cosmic landscapes. It's like watching humanity's collective unconscious process the implications of cosmic discovery, revealing our deepest hopes, fears, and aspirations about our place in the universe. The Interstellar Object Meditation Program Cosmic Consciousness. Let's explore the meditation program that has emerged from the study of 3 IATLAS, recognizing that interstellar objects have inspired feelings of awe and wonder that many people describe as spiritual or transcendent. Researchers have developed a meditation program that uses these cosmic visitors as a focus for contemplation and exploration of consciousness. Picture this. Imagine you could meditate on an object that has traveled through interstellar space for millions of years, contemplating its journey, its composition, and what it represents about the vastness and mystery of the cosmos. That's essentially what the Interstellar Object Meditation Program offers: a way to use cosmic phenomena as a gateway to expanded awareness and deeper understanding of our place in the universe. The Interstellar Object Gaming Ecosystem Cosmic Playlets explored the gaming ecosystem that has emerged from the study of 3 IATLAS, recognizing that interactive experiences can be powerful tools for education and engagement. Game developers have created a comprehensive ecosystem of games that allow players to explore, discover, and even simulate interstellar objects in ways that were previously impossible. Picture this. Imagine you could play a game where you're the astronomer who discovers the next interstellar visitor, or the engineer who designs the mission to study it, or even the explorer who travels to it in a virtual spacecraft. That's essentially what the Interstellar Object Gaming Ecosystem offers: a range of experiences that allow players to engage with cosmic phenomena from multiple perspectives and at different levels of complexity. What's particularly exciting is how this gaming ecosystem has evolved to include different types of experiences for different players. There are realistic simulation games for science enthusiasts, narrative-driven adventure games for casual players, educational games for students, and even multiplayer games where players can collaborate to study interstellar objects together. It's like watching a comprehensive digital universe develop around a cosmic phenomenon, creating experiences that are as entertaining as they are educational. The interstellar object augmented reality experience, cosmic overlay now. Let's dive into the augmented reality experience that has emerged from the study of 3I-ATLAS. Recognizing that most people experience the cosmos through screens rather than direct observation, developers have created AR applications that overlay information about interstellar objects onto the real world, creating educational and immersive experiences that blend digital and physical reality. Think about it like this. Imagine you could point your smartphone at the night sky and see the paths of interstellar objects as they pass through our solar system. Or hold up your device and see a virtual 3i atlas floating in your living room, complete with accurate information about its characteristics and journey. That's essentially what the interstellar object augmented reality experience offers, a way to bring cosmic phenomena into our everyday environment in ways that are both educational and magical. What's particularly fascinating is how this AR experience is making complex astronomical concepts accessible to people who might not engage with traditional educational materials. Instead of trying to understand abstract descriptions of interstellar objects, users can see and interact with them in their own environment. It's like watching the boundary between the cosmic and the everyday dissolve, creating experiences that make the universe feel more immediate and personal. The interstellar object holographic display cosmic projection lets explore the holographic display technology that has emerged from the study of 3I-ATLAS. The challenges of representing a three-dimensional object that exists millions of miles away have inspired the development of advanced holographic technology that can create realistic three-dimensional representations of interstellar objects that can be viewed without special glasses or equipment. Picture this. Imagine you could walk around a holographic representation of 3i Atlas, examining it from every angle, watching it tumble through space, and even seeing how light reflects off its unusual surface. That's essentially what the interstellar object holographic display technology makes possible, a way to bring cosmic visitors into our physical space in three-dimensional form. What's particularly exciting is how this holographic technology is creating new possibilities for both education and research. Students can learn about interstellar objects by examining realistic holograms. Researchers can collaborate by sharing three-dimensional representations of their discoveries. Even museums and science centers can create immersive exhibits that allow visitors to explore cosmic phenomena in unprecedented detail. It's like watching a new form of visualization technology emerge, one that bridges the gap between digital information and physical reality. The interstellar object neural interface cosmic connection. Now, let's dive into the neural interface that has emerged from the study of 3I-ATLAS in one of the more speculative and new futuristic developments inspired by this cosmic visitor. Researchers have explored the possibility of creating direct neural interfaces that would allow humans to experience interstellar objects through brain-computer interfaces rather than through traditional sensory channels. Think about it like this. Imagine you could directly experience the journey of an interstellar object through space, perceiving its environment, its movement, and even its composition through neural signals rather than through your eyes or ears. That's essentially what the interstellar object neural interface explores the possibility of creating a more direct, intuitive connection between human consciousness and cosmic phenomena. What's particularly thought-provoking is how this neural interface challenges our understanding of perception and experience. By bypassing traditional sensory channels and directly stimulating neural patterns associated with different aspects of interstellar objects. This technology could potentially allow us to experience the cosmos in ways that are fundamentally different from our normal sensory experience. It's like watching the boundary between human consciousness and the cosmos become more permeable, creating possibilities for understanding that transcend the limitations of our biological senses. The interstellar object quantum entanglement communication. Cosmic linklets explore the quantum entanglement communication system that has emerged from the study of 3IATLAS. The challenges of communicating with spacecraft that might study interstellar objects at vast distances from Earth have inspired researchers to explore the possibility of using quantum entanglement for instantaneous communication across cosmic distances. Picture this. Imagine you could communicate with a spacecraft studying an interstellar object light years away without any time delay, sending and receiving information instantaneously, regardless of distance. That's essentially what the interstellar object quantum entanglement communication system aims to achieve, a way to maintain real-time contact with cosmic explorers. No matter how far they travel, what's particularly fascinating is how this communication system leverages one of the strangest phenomena in quantum mechanics: the apparent ability of entangled particles to instantaneously affect each other regardless of distance. While this technology is still largely theoretical, it represents a potential solution to one of the fundamental challenges of deep space exploration. It's like watching humanity develop the tools it would need to truly become a spacefaring species capable of exploring the cosmos in real time, rather than with the significant time delays that currently limit our ability to venture far from Earth. The Interstellar Object Fusion Propulsion System. Cosmic Engine. Now, let's dive into the fusion propulsion system that has emerged from the study of 3I Atlas. The realization that conventional propulsion systems would be inadequate for studying interstellar objects up close has inspired the development of advanced fusion propulsion technology that could potentially allow spacecraft to match the incredible velocities of these cosmic visitors. Think about it like this. Imagine you could build a spacecraft that could accelerate to the speeds of interstellar objects, allowing you to catch up with them, study them up close, and even return samples to Earth. That's essentially what the interstellar object fusion propulsion system is designed to make possible: a new generation of space propulsion that could revolutionize our ability to explore the cosmos. What's particularly exciting is how this fusion propulsion system could transform space exploration beyond just the study of interstellar objects. With the ability to travel at much higher speeds than current spacecraft, we could explore the outer solar system, send missions to nearby stars, and even establish a human presence throughout our cosmic neighborhood. It's like watching the development of the technology that would allow humanity to truly become a multi-planetary species, with the ability to explore and potentially even settle worlds far beyond Earth. The interstellar object self-replicating probe. Cosmic Seed. Let's explore the self-replicating probe concept that has emerged from the study of 3IATLAS, recognizing that the vastness of space makes it impracticable to explore every interstellar object with individually launched spacecraft from Earth. Researchers have developed the concept of self-replicating probes that could explore the cosmos exponentially, creating copies of themselves as they travel. Picture this. Imagine you could launch a single spacecraft that could travel to an interstellar object, study it, and then use materials from that object or from asteroids and comets along the way to create copies of itself, which could then travel to other interstellar objects and repeat the process. That's essentially what the interstellar object self-replicating probe concept envisions, a way to explore the cosmos that grows exponentially rather than linearly. The Interstellar Object Planetary Protection Protocol, Cosmic Quarantine lets explore the planetary protection protocol that has emerged from the study of 3IATLAS. The realization that interstellar objects might potentially carry biological material or other contaminants has inspired the development of comprehensive protocols to protect both Earth from potential extraterrestrial contaminants and other worlds from contamination by Earth organisms. Picture this. Imagine you're bringing back samples from an interstellar object and you need to ensure that any potential alien microorganisms don't escape into Earth's ecosystem, while also making sure that Earth microbes don't contaminate the samples or any other worlds you might visit. That's essentially what the Interstellar Object Planetary Protection Protocol addresses, the challenge of exploring the cosmos responsibly while protecting all forms of life. What's particularly fascinating is how this protocol represents a new level of cosmic responsibility. As we become more capable of exploring and even traveling to other star systems, we also become more capable of inadvertently causing harm through the introduction of Earth organisms to alien environments or alien organisms to Earth. It's like watching humanity develop its cosmic environmental ethics, recognizing that with greater exploration capability comes greater responsibility to protect the cosmic web of life. The Interstellar Object Emergency Response System. Cosmic Alert Now. Let's dive into the emergency response system that has emerged from the study of 3IATLAS, the recognition that some interstellar objects might pose potential threats, whether through impact with Earth or other more speculative scenarios, has inspired the development of a comprehensive emergency response system that could coordinate global action if needed. Think about it like this. Imagine you detect an interstellar object that's on a potential collision course with Earth, or that exhibits characteristics suggesting it might be artificial or even potentially hostile. How would you coordinate a global response? That's essentially what the Interstellar Object Emergency Response System is designed to address, the challenge of responding quickly and effectively to potential cosmic threats or opportunities. What's particularly interesting is how this emergency response system balances preparation with prevention. On one hand, it includes protocols for rapid response if an interstellar object poses a potential threat. On the other hand, it includes detection and monitoring systems designed to provide as much warning as possible, increasing the range of response options. It's like watching humanity develop its cosmic civil defense system, creating the infrastructure needed to protect Earth from potential cosmic hazards, while remaining open to the possibilities of peaceful contact and discovery. The Interstellar Object Public Engagement Platform. Cosmic Communicators explore the public engagement platform that has emerged from the study of 3I ATLAS, recognizing that interstellar objects have captured the public imagination in ways that typical scientific discoveries rarely do. Researchers have developed a comprehensive platform that allows people around the world to engage with the latest discoveries and even contribute to research. Picture this. Imagine you could visit a website or app where you could see the latest data about interstellar objects, watch live feeds from observatories, participate in citizen science projects, and even connect with other enthusiasts around the world. That's essentially what the Interstellar Object Public Engagement Platform provides, a digital space where anyone can engage with cosmic exploration and discovery. What's particularly exciting is how this platform is creating a global community of cosmic enthusiasts. Instead of passively consuming information about interstellar objects through traditional media, users can actively participate in the discovery process, contribute their own observations and analyses, and even collaborate with professional research. It's like watching the development of a global citizen science movement focused on the cosmos, creating opportunities for anyone with curiosity and passion to contribute to our understanding of the universe. The Interstellar Object Educational Curriculum, Cosmic Learning Now. Let's dive into the educational curriculum that has emerged from the study of 3I ATLAS. Recognizing that interstellar objects represent a perfect opportunity to engage students with science, technology, engineering, and mathematics, STEM educators have developed a comprehensive curriculum that uses these cosmic visitors as a teaching tool across multiple subjects and grade levels. Think about it like this. Imagine you could learn about physics by studying the trajectory of an interstellar object, chemistry by analyzing its composition, geology by examining its surface features, and even literature and art by exploring how these cosmic visitors inspire human creativity. That's essentially what the Interstellar Object Educational Curriculum offers, a way to make abstract scientific concepts tangible and exciting through real cosmic phenomena. What's particularly fascinating is how this curriculum is designed to be adaptable for different educational contexts and cultural backgrounds, whether you're teaching elementary school students in rural America or high school students in urban Asia. The fundamental wonder of an object from beyond our solar system can serve as a universal entry point to scientific inquiry. It's like watching the development of a truly global approach to science education, one that leverages our shared cosmic curiosity to create learning experiences that transcend cultural and geographical boundaries. The Interstellar Object Virtual Reality Laboratory Cosmic Simulation. Let's explore the virtual reality laboratory that has emerged from the study of 3I ATLAS. The challenges of studying objects that are millions of miles away have inspired the development of comprehensive VR environments that allow researchers and students to simulate and explore interstellar objects in ways that would be impossible through direct observation alone. Picture this. Imagine you could put on a VR headset and find yourself floating next to an interstellar object, able to examine its surface, structure, and composition in three-dimensional detail, or even run simulations to see how it might behave under different conditions. That's essentially what the Interstellar Object Virtual Reality Laboratory provides: an immersive environment for cosmic exploration and experimentation. What's particularly exciting is how this VR laboratory is creating new possibilities for both research and education. Researchers can test hypotheses about interstellar objects in a controlled virtual environment before attempting to verify them through observation or experimentation. Students can develop intuitive understanding of complex cosmic phenomena through direct, interactive experience rather than abstract description. It's like watching the development of a new form of scientific intuition, one that combines the rigor of traditional scientific method with the immersive power of virtual reality. The Interstellar Object Artificial Intelligence Research Assistant Cosmic Colleague. Let's dive into the AI research assistant that has emerged from the study of 3I-ATLAS. The complexity and volume of data generated by interstellar object research have inspired the development of specialized AI systems that can assist researchers with everything from data analysis to hypothesis generation. Think about it like this. Imagine you had a research assistant that could process vast amounts of astronomical data, identify patterns that humans might miss, suggest promising areas for investigation, and even help write and review research papers. That's essentially what the Interstellar Object Artificial Intelligence Research Assistant aims to be: a digital colleague that can augment human intelligence and capabilities in the study of cosmic phenomena. What's particularly fascinating is how this AI assistant is evolving beyond simple data processing to become something more like a scientific collaborator. By training on vast amounts of astronomical data and research literature, these systems can identify connections between different fields of study, suggest interdisciplinary approaches, and even generate novel hypotheses that human researchers might not have considered. It's like watching the emergence of a new form of scientific intelligence, one that combines the computational power of machines with the curiosity and creativity that drives human inquiry. The Interstellar Object Global Observation Network Cosmic Telescopelets explore the global observation network that has emerged from the study of 3I-ATLAS. Recognizing that tracking and studying interstellar objects requires continuous observation from multiple locations around the world, researchers have developed a coordinated network of telescopes and other instruments that work together as a single, unified system. Picture this. Imagine you had a network of telescopes spanning the globe, all working together to track interstellar objects as they pass through our solar system, with instruments automatically coordinating to provide continuous coverage as the Earth rotates. That's essentially what the Interstellar Object Global Observation Network represents: a worldwide system for cosmic surveillance and research. The Interstellar Object Quantum Communication Network Cosmic Connection. Let's explore the quantum communication network that has emerged from the study of 3I-ATLAS. The challenges of communicating with spacecraft that might study interstellar objects at vast distances from Earth have inspired researchers to develop a quantum communication system that could potentially enable secure, instantaneous communication across cosmic distances. Picture this. Imagine you could send a message to a spacecraft studying an interstellar object light years away and receive an immediate response. with the communication being completely secure against interception or eavesdropping. That's essentially what the interstellar object quantum communication network aims to achieve, a new form of cosmic communication that leverages the strange properties of quantum mechanics. What's particularly fascinating is how this quantum communication network could transform not just space exploration but communication on Earth as well, by developing systems that can maintain quantum entanglement over vast distances. Researchers are creating technologies that could enable unhackable communication networks, revolutionizing everything from financial transactions to diplomatic communications. It's like watching the development of a technology that could fundamentally change how we connect with each other, both on Earth and across the cosmos. The Interstellar Object Multispectral Observatory. Cosmic Vision. Now let's dive into the multispectral observatory that has emerged from the study of 3I ATLAS, the limitations of observing cosmic objects through only the visible spectrum have inspired the development of a comprehensive observatory that can simultaneously study interstellar objects across multiple wavelengths of light, from radio waves to gamma rays. Think about it like this. Imagine you could look at an interstellar object and see it not just in visible light, but also in infrared, ultraviolet, X-rays, and other parts of the electromagnetic spectrum, all at the same time revealing different aspects of its composition and behavior. That's essentially what the Interstellar Object Multispectral Observatory provides, a more complete picture of cosmic phenomena than was previously possible. What's particularly exciting is how this multispectral approach is revealing aspects of interstellar objects that were completely invisible when observing through only a single part of the spectrum. Different wavelengths reveal different materials, temperatures, and processes, creating a comprehensive understanding that's far greater than the sum of its parts. It's like watching humanity develop a more complete set of eyes for viewing the cosmos, one that can see the universe in all its spectral richness, rather than just the narrow band of visible light that our eyes evolved to detect. The Interstellar Object Gravitational Wave Detector. Cosmic Ears, let's explore the gravitational wave detector that has emerged from the study of 3IATLAS. The recognition that some interstellar objects might interact with gravitational fields in unusual ways has inspired the development of specialized gravitational wave detectors, designed to sense the ripples in space-time that these cosmic visitors might create. Picture this. Imagine you could hear an interstellar object passing through our solar system, not through light or radio waves, but through the gravitational waves it creates as it moves through space, potentially revealing aspects of its mass, composition, and even origin that can't be determined through electromagnetic observation alone. That's essentially what the Interstellar Object Gravitational Wave Detector aims to achieve, a new way of sensing cosmic phenomena. What's particularly fascinating is how this gravitational wave detection approach could reveal aspects of interstellar objects that are completely invisible to traditional observation. Just as visible light shows us different aspects of the universe than radio waves or X-rays, gravitational waves could provide an entirely new window into cosmic phenomena, potentially revealing properties of interstellar objects that we can't even imagine yet. It's like watching humanity develop a new sense for perceiving the cosmos, one that can feel the ripples in space-time rather than just seeing the light that travels through it. The Interstellar Object Neutrino Observatory, Cosmic Ghost Detector. Now, let's dive into the Neutrino Observatory that has emerged from the study of 3I ATLAS. The possibility that some interstellar objects might emit or interact with neutrinos, particles that can pass through almost any material without being stopped, has inspired the development of specialized detectors designed to sense these ghost particles as they pass through Earth. Think about it like this. Imagine you could detect an interstellar object not by the light it reflects or the radio waves it emits, but by the neutrinos it produces or interacts with, potentially revealing processes happening deep within its interior that are completely hidden from traditional observation. That's essentially what the Interstellar Object Neutrino Observatory aims to achieve, a way to see inside cosmic visitors rather than just observing their surfaces. What's particularly interesting is how neutrino detection could provide information about interstellar objects that's simply impossible to obtain through other means, because neutrinos can pass through almost any material. They can carry information from the deep interiors of objects, revealing processes and compositions that are completely hidden from external observation. It's like watching humanity develop X-ray vision for the cosmos, able to see inside objects rather than just observing their external appearance. The Interstellar Object Dark Matter Detector Cosmic Shadowlets explore the dark matter detector that has emerged from the study of 3I ATLAS, the speculative possibility that some interstellar objects might interact with or even be composed of dark matter has inspired the development of specialized detectors designed to sense the presence of this mysterious substance that makes up most of the universe's mass but remains invisible to traditional observation. Picture this. Imagine you could detect an interstellar object not by the light it reflects or the radiation it emits, but by the way it interacts with dark matter or the dark matter that might compose it, potentially revealing a completely new class of cosmic objects that we've never been able to observe before. That's essentially what the Interstellar Object Dark Matter Detector aims to achieve, a way to see the invisible majority of the cosmos. What's particularly exciting is how this dark matter detection approach could revolutionize our understanding of the universe. If we could detect and study interstellar objects that interact with or are composed of dark matter, we might finally solve one of the greatest mysteries in modern physics: what exactly dark matter is and how it behaves. It's like watching humanity develop the ability to see the cosmic ocean that we've known exists through its gravitational effects but have never been able to observe directly. The Interstellar Object Exotic Matter Detector Cosmic Anomaly. Let's dive into the exotic matter detector that has emerged from the study of 3I ATLAS. The unusual characteristics of this cosmic visitor have led some researchers to speculate that it might contain forms of matter that don't exist in our solar system, inspiring the development of detectors designed to identify these potentially exotic materials. Think about it like this. Imagine you could analyze an interstellar object and detect elements, isotopes, or even states of matter that don't exist naturally on Earth or in our solar system, potentially revealing physical processes or conditions that occur in other parts of the galaxy. That's essentially what the interstellar object exotic matter detector aims to achieve, a way to identify cosmic materials that are completely alien to our corner of the universe. What's particularly fascinating is how this exotic matter detection could revolutionize our understanding of physics and chemistry by identifying materials that don't exist in our solar system. We might discover new elements, new chemical compounds, or even new states of matter that could transform everything, from materials science to our understanding of fundamental physical laws. It's like watching humanity develop the ability to discover and study materials that could be as revolutionary as the discovery of fire or metals was for our ancestors. The Interstellar Object Temporal Anomaly Detector Cosmic Timelets explore the temporal anomaly detector that has emerged from the study of 3 IATLAS. Some of the more speculative theories about this cosmic visitor suggest it might exhibit unusual temporal characteristics, inspiring the development of detectors designed to sense any anomalies in how time passes around or within the object. Picture this. Imagine you could detect an interstellar object not just by its position in space, but by its unique relationship to time, perhaps experiencing time at a different rate, or even exhibiting temporal properties that challenge our understanding of causality and sequence. That's essentially what the Interstellar Object Temporal Anomaly Detector aims to achieve. A way to sense cosmic phenomena that might exist outside our normal experience of time. The Interstellar Object Exotic Physics Detector Cosmic Anomaly. Let's explore the exotic physics detector that has emerged from the study of 3 IATLAS. The unusual characteristics of this cosmic visitor have led researchers to develop specialized detectors designed to identify any phenomena that might operate according to physical principles beyond our current understanding. Picture this. Imagine you could detect an interstellar object not just by its known physical properties, but by any anomalies that might indicate it's operating according to laws of physics we haven't yet discovered. That's essentially what the Interstellar Object Exotic Physics Detector aims to achieve, a way to identify cosmic phenomena that could revolutionize our understanding of reality itself. What's particularly exciting is how this exotic physics detection approach could reveal that the universe operates according to principles that are completely different from what we currently understand. If we could detect and study phenomena that exhibit these exotic physical properties, we might need to completely rewrite our understanding of physics, potentially opening up new possibilities for technology, energy, and even our conception of reality itself. It's like watching humanity develop the ability to perceive aspects of the cosmos that operate according to rules we haven't even imagined yet, potentially revealing a universe that's stranger and more wonderful than our current theories can predict. The Interstellar Object Biological Signature Detector Cosmic Life Now. Let's dive into the biological signature detector that has emerged from the study of 3 IATLAS. The possibility that interstellar objects might carry biological material or even life forms has inspired the development of specialized detectors designed to identify any signs of biological activity or organic compounds. Think about it like this. Imagine you could analyze an interstellar object and detect not just its chemical composition, but specific signatures that would indicate the presence of biological processes or organic materials that could be precursors to life. That's essentially what the Interstellar Object Biological Signature Detector aims to achieve, a way to search for signs of life beyond Earth. What's particularly profound is how this biological signature detection approach could answer one of humanity's most fundamental questions: does life exist beyond Earth? If we could detect biological materials or even living organisms on interstellar objects, we might discover that life is not unique to our planet, but is a cosmic phenomenon that exists throughout the galaxy. It's like watching humanity develop. The ability to search for our cosmic neighbors, potentially discovering that we share the universe with other forms of life, whether microbial or complex, whether similar to Earth life or radically different. The Interstellar Object Technosignature Detector Cosmic Technologies explore the technosignature detector that has emerged from the study of 3I ATLAS. The possibility that some interstellar objects might be artificial rather than natural has inspired the development of specialized detectors designed to identify any signs of artificial origin or technological modification. Picture this. Imagine you could analyze an interstellar object and detect not just its natural properties, but specific signatures that would indicate it was created or modified by an intelligent civilization, whether through its shape, composition, or emissions. That's essentially what the Interstellar Object Technosignature Detector aims to achieve, a way to search for evidence of extraterrestrial technology. What's particularly fascinating is how this technosignature detection approach could provide evidence for the existence of extraterrestrial intelligence without requiring direct communication or contact. If we could detect objects that are clearly artificial in origin, we might discover that we shared the cosmos with other technological civilizations, potentially revolutionizing our understanding of our place in the universe. It's like watching humanity develop the ability to search for cosmic artifacts that might be the equivalent of alien tools, spacecraft, or even monuments, potentially revealing that we're not the only intelligent species to have looked up at the stars and wondered, what's out there? The Interstellar Object Navigation Beacon System, Cosmic Signpost. Now, let's dive into the navigation beacon system that has emerged from the study of 3I ATLAS. The challenges of tracking and studying objects that pass through our solar system relatively quickly have inspired the development of a network of navigation beacons that could help future spacecraft intercept and study these cosmic visitors. Think about it like this. Imagine you had a network of beacons throughout the solar system that could help spacecraft navigate to interstellar objects, providing precise positioning and timing information that would make interception possible even with objects moving at incredible velocities. That's essentially what the Interstellar Object Navigation Beacon System aims to provide, a cosmic GPS for studying visitors from beyond our solar system. What's particularly exciting is how this navigation beacon system could transform our ability to study interstellar objects up close. Instead of having only brief opportunities for distant observation as objects pass through our solar system, we could potentially send spacecraft to rendezvous with them, study them at length, and even return samples to Earth. It's like watching humanity develop the infrastructure needed to become active participants in the cosmic ecosystem rather than just passive observers. potentially opening a new era of exploration and discovery, the Interstellar Object Sample Containment Facility. Cosmic Quarantine lets explore the sample containment facility that has emerged from the study of 3 IAT-LAS, the desire to return samples from interstellar objects to Earth for detailed study has inspired the development of advanced containment facilities that could house these samples safely without risk of contamination to either Earth or the samples. Picture this. Imagine you could bring back a sample from an interstellar object and study it in a facility that provided perfect isolation, preventing any potential alien microorganisms from escaping into Earth's ecosystem while also protecting the sample from contamination by Earth organisms. That's essentially what the Interstellar Object Sample Containment Facility aims to provide: a safe environment for studying cosmic materials. What's particularly important is how this containment facility represents our growing understanding of the need for cosmic responsibility as we become more capable of exploring and even bringing back materials from other star systems. We also need to develop the wisdom to do so safely, protecting both our own planet and any potential alien ecosystems we might encounter. It's like watching humanity develop its cosmic environmental ethics, recognizing that with greater exploration capability comes greater responsibility to protect all forms of life, whether terrestrial or extraterrestrial. The Interstellar Object Research Vessel Fleet. Cosmic Explorers now. Let's dive into the research vessel fleet that has emerged from the study of 3 IAT-LAS. The recognition that a single spacecraft might not be sufficient to study the diverse range of interstellar objects that pass through our solar system has inspired plans for a fleet of specialized research vessels, each designed for different types of interstellar object research. Think about it like this. Imagine you had a fleet of spacecraft, each specialized for different aspects of interstellar object research, some designed for rapid interception, others for detailed analysis, still others for sample return, all working together to create a comprehensive understanding of these cosmic visitors. That's essentially what the Interstellar Object Research Vessel Fleet aims to be: a diverse team of cosmic explorers. What's particularly exciting is how this fleet approach would allow us to study interstellar objects much more comprehensively than would be possible with a single spacecraft. By having different vessels with different capabilities, we could tailor our response to each interstellar object based on its specific characteristics, potentially learning more about the diversity of these cosmic visitors and what they can tell us about the broader galaxy. It's like watching humanity develop a comprehensive exploration strategy for the cosmos, creating the tools needed to understand our place in the universe in all its complexity and diversity. The Interstellar Object International Research Station. Cosmic Outpost. Let's explore the International Research Station that has emerged from the study of 3 IAT-LAS. The recognition that studying interstellar objects requires a coordinated global response has inspired plans for a dedicated research station where scientists from around the world could collaborate on the study of these cosmic visitors. Picture this. Imagine you had a research station, perhaps in orbit around Earth, on the Moon, or even at a stable Lagrange point specifically designed for the study of interstellar objects, with laboratories, observation facilities, and even spacecraft. for studying these visitors up close. That's essentially what the Interstellar Object International Research Station aims to be: a dedicated outpost for cosmic research. The Interstellar Object Future Scenarios Project, Cosmic Possibilities. Let's explore the Future Scenarios Project that has emerged from the study of 3.1 ATLAS. Recognizing that interstellar objects could represent anything from natural phenomena to evidence of extraterrestrial intelligence, researchers have developed a comprehensive project to explore and prepare for various future scenarios that might unfold as we continue to study these cosmic visitors. Picture this. Imagine you could simulate and prepare for every possible scenario that might unfold as we study interstellar objects. From confirming their entirely natural phenomena to discovering they're artificial, from finding they carry biological materials to learning they're part of a broader cosmic network of intelligent civilizations. That's essentially what the Interstellar Object Future Scenarios Project aims to achieve: a comprehensive preparation for the cosmic possibilities that might await us. What's particularly fascinating is how this Scenarios project is helping humanity think more systematically about its place in the cosmos. Instead of reacting to discoveries as they happen, we're proactively considering the possibilities and developing appropriate responses for each. It's like watching humanity develop its cosmic strategic planning, creating the frameworks needed to respond thoughtfully and responsibly to whatever the universe might reveal as we continue our exploration of interstellar objects. The Interstellar Object Public Policy Framework. Cosmic governance now. Let's dive into the public policy framework that has emerged from the study of 3.1 ATLAS. Recognizing that interstellar objects raise complex questions about jurisdiction, resource rights, planetary protection, and even potential contact with extraterrestrial intelligence. Policymakers have developed a comprehensive framework to address these issues. Think about it like this. Imagine you had to create policies for how humanity should handle objects that don't belong to any nation, that might carry valuable resources or potential dangers, and that might even represent contact with other intelligent civilizations. That's essentially the challenge that the Interstellar Object Public Policy Framework addresses: the need for governance structures that can handle the complexities of cosmic exploration and discovery. What's particularly important is how this policy framework represents humanity's growing maturity as a species. Instead of approaching cosmic exploration with a competitive, nationalistic mindset, we're developing international frameworks that prioritize the collective good of all humanity. It's like watching humanity develop its cosmic governance structures, creating the rules and institutions needed to explore the universe responsibly and ethically. The Interstellar Object Ethical Review Board. Cosmic Conscience. Let's explore the Ethical Review Board that has emerged from the study of 3.1 ATLAS. Recognizing that interstellar objects raise profound ethical questions about everything from sample return to potential contact with extraterrestrial intelligence, researchers have established a comprehensive ethical review process to consider the implications of different research approaches. Picture this. Imagine you had a board of ethicists, scientists, theologians, and representatives from different cultures who would review proposed research on interstellar objects to ensure it was conducted responsibly, with consideration for both potential risks and broader ethical implications. That's essentially what the Interstellar Object Ethical Review Board provides: a systematic approach to the ethical dimensions of cosmic exploration. What's particularly inspiring is how this ethical review board represents humanity's growing awareness of the need for cosmic responsibility. As we become more capable of exploring and potentially interacting with aspects of the cosmos beyond our solar system, we're also developing the wisdom to consider the ethical implications of our actions. It's like watching humanity develop its cosmic conscience, creating the moral frameworks needed to explore the universe, not just capably, but wisely. The Interstellar Object Risk Assessment Protocol, Cosmic Safety Now. Let's dive into the Risk Assessment Protocol that has emerged from the study of 3I-ATLAS, recognizing that interstellar objects could potentially pose various risks, from impact with Earth to biological contamination to more speculative threats. Researchers have developed a comprehensive protocol for assessing and managing these risks. Think about it like this. Imagine you had a systematic way to evaluate every potential risk associated with interstellar objects, from the most likely to the most speculative, and to develop appropriate responses for each level of risk. That's essentially what the Interstellar Object Risk Assessment Protocol provides: a framework for cosmic safety that balances preparation with prevention. What's particularly interesting is how this risk assessment protocol manages to be both comprehensive and proportional. It addresses even the most speculative risks while focusing resources on the most likely scenarios, creating a balanced approach to cosmic safety that neither ignores potential dangers nor overreacts to unlikely possibilities. It's like watching humanity develop its cosmic risk management, creating the systems needed to explore the universe boldly but responsibly. The Interstellar Object Benefit Sharing Framework, Cosmic Equity. Let's explore the benefit sharing framework that has emerged from the study of 3I-ATLAS, recognizing that discoveries and resources related to interstellar objects could potentially have significant commercial or scientific value. Policymakers have developed a framework to ensure that these benefits are shared equitably among all nations and peoples. Picture this. Imagine you discovered that interstellar objects contained valuable materials or knowledge, and you had to decide how to ensure that these benefits didn't just enrich a few countries or corporations, but were shared in a way that benefited all of humanity. That's essentially what the Interstellar Object Benefit Sharing Framework aims to achieve: an equitable approach to the distribution of cosmic resources and knowledge. What's particularly inspiring is how this benefit sharing framework represents humanity's highest aspirations for fairness and cooperation. Instead of allowing cosmic exploration to become another arena for competition and inequality, we're proactively creating systems to ensure that the benefits of discovery are shared by all. It's like watching humanity develop its cosmic economic justice, creating the frameworks needed to explore the universe in a way that lifts everyone up rather than creating new divisions. The Interstellar Object Cultural Heritage Protection Protocol, Cosmic Preservation Now. Let's dive into the Cultural Heritage Protection Protocol that has emerged from the study of 3I-ATLAS, recognizing that some interstellar objects might be artificial or might have cultural significance that we don't yet understand. Researchers have developed protocols to protect these potential cosmic cultural heritage sites. Think about it like this. Imagine you discovered that an interstellar object was actually an artifact from an ancient extraterrestrial civilization, and you had to decide how to study it without destroying or disturbing this cosmic cultural heritage. That's essentially what the Interstellar Object Cultural Heritage Protection Protocol addresses: the need to preserve and respect potential cosmic cultural sites. What's particularly fascinating is how this Cultural Heritage Protocol represents humanity's growing recognition that the cosmos might contain not just natural wonders, but cultural ones as well. By developing protocols to protect potential cosmic cultural heritage, we're acknowledging that we might not be the first or only intelligent species to have left our mark on the universe. It's like watching humanity develop its cosmic archaeology and preservation ethics, creating the frameworks needed to explore the universe with respect for whatever or whoever might have come before us. The Interstellar Object Public Engagement Strategy. Cosmic Conversation. Let's explore the public engagement strategy that has emerged from the study of 3 IAT LAS. Recognizing that interstellar objects have captured the public imagination in ways that typical scientific discoveries rarely do, researchers have developed a comprehensive strategy to keep the public informed and involved in discoveries as they unfold. Think about it like this. Imagine you had a strategy for sharing discoveries about interstellar objects with the public in a way that was accurate, accessible, and engaging, allowing everyone to participate in the excitement of cosmic discovery. That's essentially what the Interstellar Object Public Engagement Strategy aims to achieve: a way to make cosmic exploration a shared human experience, rather than something that happens behind closed laboratory doors. What's particularly exciting is how this public engagement strategy is creating a more inclusive approach to scientific discovery. Instead of treating the public as passive recipients of scientific knowledge, it invites active participation and dialogue, creating opportunities for everyone to contribute to our understanding of the cosmos. It's like watching humanity develop its approach to democratic science, creating the channels needed for cosmic exploration to be a truly collective human endeavor. The Interstellar Object Education Pipeline, Cosmic Workforce. The Interstellar Object Humanity Integration Project. Cosmic Evolution. Let's explore the Humanity Integration Project that has emerged from the study of 3 IAT LAS. Recognizing that the discovery of interstellar objects represents not just a scientific milestone but a potential turning point in human evolution. Researchers have developed a comprehensive project to help humanity integrate the implications of these discoveries into our collective consciousness and social structures. Picture this. Imagine you could help humanity adapt to the realization that we're part of a much larger cosmic ecosystem, developing the psychological, social, and cultural frameworks needed to thrive in a universe that's suddenly become much bigger and more populated than we thought. That's essentially what the Interstellar Object Humanity Integration Project aims to achieve: a guided evolution of human consciousness and society to embrace our cosmic identity. What's particularly profound is how this integration project recognizes that the greatest challenge of interstellar objects might not be technological or scientific, but psychological and cultural, adapting to the reality that we might share the cosmos with other intelligences, other civilizations, or even other forms of life requires a fundamental shift in how we understand ourselves and our place in the universe. It's like watching humanity undergo a collective growth process, maturing from a species that saw itself as the center of the universe to one that understands itself as part of a much larger cosmic community. The Interstellar Object Consciousness Expansion Initiative. Cosmic Awareness Now. Let's dive into the Consciousness Expansion Initiative that has emerged from the study of 3I ATLAs, recognizing that interstellar objects challenge our most fundamental assumptions about reality, consciousness, and existence itself. Have developed programs designed to help expand human consciousness to accommodate these cosmic revelations. Think about it like this. Imagine you could participate in practices and experiences designed to expand your consciousness beyond its normal limitations, allowing you to perceive and understand aspects of reality that are currently beyond your comprehension. That's essentially what the Interstellar Object Consciousness Expansion Initiative offers: a systematic approach to developing the cognitive and perceptual capacities needed to understand a universe that might be far stranger and more wonderful than we currently imagine. What's particularly fascinating is how this consciousness expansion initiative bridges the gap between science and spirituality, using insights from both traditions to help humanity develop the expanded awareness needed to comprehend cosmic realities. It's like watching humanity develop new forms of consciousness and perception, evolving beyond the cognitive limitations that have served us well on Earth, but might be inadequate for understanding the broader cosmos. The Interstellar Object Universal Perspective Program. Cosmic Wisdom. Let's explore the Universal Perspective Program that has emerged from the study of 3I ATLAs, recognizing that interstellar objects naturally inspire a more cosmic perspective on human existence. Educators and philosophers have developed programs designed to help people cultivate this universal viewpoint in their daily lives. Picture this. Imagine you could train yourself to naturally see your personal concerns, your community's challenges, and even humanity's problems from a cosmic perspective, recognizing how small yet how precious our existence is in the vastness of space and time. That's essentially what the Interstellar Object Universal Perspective Program aims to cultivate, a way of seeing that balances the cosmic scale with the intimate value of human experience. What's particularly transformative is how this universal perspective program can help address many of humanity's most persistent problems. By naturally seeing ourselves as part of a larger cosmic ecosystem, we might find it easier to address global challenges like climate change, inequality, and conflict. Recognizing how precious and rare our planetary home is in the vastness of the cosmos. It's like watching humanity develop its cosmic wisdom, learning to balance our immediate concerns with the long-term perspective that comes from understanding our place in the universe. The Interstellar Object Existential Integration Framework. Cosmic meaning. Now, let's dive into the existential integration framework that has emerged from the study of 3I Atlas. Recognizing that interstellar objects raise profound questions about meaning, purpose, and the nature of existence itself, psychologists and philosophers have developed frameworks to help people integrate these cosmic questions into their understanding of their lives and the world. Think about it like this. Imagine you had a framework that could help you find meaning and purpose, not in spite of the vastness of the cosmos, but because of it. Recognizing how your individual life contributes to the universe's experience of itself. That's essentially what the interstellar object existential integration framework provides, a way to find cosmic significance in our individual and collective lives. What's particularly inspiring is how this existential integration framework transforms what might initially seem like a crisis of meaning, the realization that we're small in a vast universe, into an opportunity for deeper meaning and purpose. By understanding ourselves as the universe's way of experiencing itself, we can find profound significance in our individual lives and collective endeavors. It's like watching humanity develop its cosmic spirituality, finding meaning not by being the center of everything, but by being part of everything. The Interstellar Object Cultural Transformation Initiative, Cosmic Renaissance. Let's explore the cultural transformation initiative that has emerged from the study of 31ATLAS. Recognizing that the discovery of interstellar objects has implications that extend far beyond science into every aspect of human culture, artists, writers, musicians, and cultural creators have developed initiatives to help transform human culture to embrace our cosmic identity. Picture this. Imagine you could participate in a cultural renaissance where art, literature, music, film, and other creative expressions all explored the implications of humanity's place in the cosmos, creating new myths, stories, and cultural forms that reflect our expanded understanding of ourselves and the universe. That's essentially what the Interstellar Object Cultural Transformation Initiative aims to inspire, a flourishing of cosmic creativity that helps humanity integrate its new identity. What's particularly exciting is how this cultural transformation is creating new forms of art and expression that speak to something fundamental about the human experience in a cosmic context. By exploring our relationship to the cosmos through creative expression, artists are helping develop the cultural frameworks needed for humanity to thrive as a cosmic species. It's like watching humanity develop its cosmic culture, creating the stories, symbols, and shared meanings that will guide us as we continue our journey into the universe. The Interstellar Object Educational Evolution. Cosmic Learning Now. Let's dive into the educational evolution that has emerged from the study of 3IATLAS, recognizing that traditional educational systems were designed for a world where humanity saw itself as the center of creation. Educators have developed new approaches to learning that prepare students for a future where we understand ourselves as part of a much larger cosmic ecosystem. Think about it like this. Imagine you could receive an education that naturally integrated cosmic perspectives into every subject, from literature to history to mathematics to science, helping you develop the knowledge and skills needed to thrive in a universe that's suddenly become much bigger and more complex than we previously thought. That's essentially what the Interstellar Object Educational Evolution aims to provide, a cosmic approach to learning that prepares humanity for its future. What's particularly inspiring is how this educational evolution is creating learning experiences that are not just more comprehensive, but also more engaging and meaningful. By connecting every subject to the cosmic context in which we exist, educators are helping students see the relevance and wonder of what they're learning, potentially transforming education from something that feels abstract and disconnected to something that feels immediately relevant to their lives and our collective future. It's like watching humanity develop its cosmic educational system, creating the learning experiences needed to prepare future generations for the challenges and opportunities of cosmic exploration and understanding. The Interstellar Object Social Adaptation Framework. Cosmic Society. Let's explore the social adaptation framework that has emerged from the study of 3I-80LAS, recognizing that the discovery of interstellar objects has implications for how we organize our societies. Economists, political scientists, and sociologists have developed frameworks to help human social structures adapt to our expanding understanding of the cosmos. Picture this. Imagine you had social, political, and economic systems that naturally operated with an awareness of our place in the cosmos, making decisions not just for immediate benefit, but with consideration for their impact on our cosmic future and potential. Relationship with other cosmic beings. That's essentially what the Interstellar Object Social Adaptation Framework aims to achieve: societies that are prepared for humanity's cosmic future.